Good morning. I can hear you perfectly, Macarena. You, me too? Me too? Yes, you can hear me. Great. Yeah. Yes, so I will start the presentation from my desktop. Yes. I send it to Alicia or to Clara, but yeah, you Alicia. Okay. Yes, I can't see her. Sorry. So okay. Then you before that you have to give me the rights. Yeah. It was in Zoom, as I remember. Moment, I will try. Ah, yeah. Send access. Ask for access here. It asks me. Okay, then I can share my screen. Mm-hmm. Great. Yeah, thank you. And
Hello, everyone. Welcome to Sevilla. We will wait 5 minutes approximately because we miss 5 persons, so we wait for them. Good morning, everyone, and welcome to the Neocycle Stakeholder Workshop here in beautiful Sevilla, but with a rainy day today. We also welcome to online attendance. We are delighted to have you join us today, both in person and virtually, for this important gathering of minds and expertise. Today, we will explore the strategic alignment of Neocycle project, its synergies with public clusters, and the exciting opportunities for collaboration with the stakeholders. Let's begin with the first of the 3 sessions, session 1, Neocycle Strategic Alignment, where we will dive into the project's core goals, activities, and current outcomes. Please welcome to Macarena from IDNR, who will introduce the Neocycle project and consortium.
Thank you, Clara, for the presentation. Okay, I'm going to check this. Ah, okay. Perfect. I was quicker. Perfecto. Gracias. Thank you, Clara, for the presentation, and welcome everyone to the first stakeholders meeting of Neocycle project here in Seville. As Clara said, my name is Macarena Garcia, and I am part of the coordination team of Neocycle project. So please be very welcome to this event. And first of all, I would like to thank the Very Unsustainable Mining Clustering for the organization, of course, of this event. Everything is perfect as usual, so thank you very, very much for your efforts here. So, first I'm going to do a brief presentation just about an introduction of a Neocycle project, so you can see what the main goals and the main activities of Neocycle are, and to know a little bit our consortium and this actual stage of the project. So, the first thing is where is Neocycle framed? Neocycle is a research innovation action project from the Horizon Europe program. We started our project in September last year, so now we have achieved the first year of the lifetime of the project. And the project duration is 48 months, and we are a very varied and huge consortium of 23 partners. So, we are from IDNR, actually. I'm here with my colleagues Maria and Anna, and we are the coordinators of Neocycle, as I mentioned. So, regarding the consortium of Neocycle, as I mentioned, we are a very huge consortium, a very big consortium formed by 23 members. So, and in this consortium, for example, we can see that there are a lot of institutions from many different countries for all along Europe, okay? So we have here partners from Spain, Germany, Italy, Poland, Lithuania, Hungary, Ukraine, Austria, Romania, Portugal, Greece, and Switzerland. So actually we are kind of extended from all over Europe. And as I mentioned, this consortium is not only big, but also very varied. So we are formed by a very different type of institutions. So within them, we can find a lot of public and private research centers, and also NGOs. Even we have Casale, a large company. Then we have different small and medium enterprises all over Europe. Then some other universities, public authorities, even here in Italy with Regione Lombardia, and even non-profit organizations. So in this sense, the consortium is very complete and very multidisciplinary. So we can dedicate our efforts in many different sectors and ways. Okay, so regarding the summary, or regarding maybe the main objectives of NeoCycle, this project aims to demonstrate the sustainability of the upcycling of already spent neodymium iron and boron magnets coming from hard disk drives. So in this sense, once we advance in the upcycling of these magnets, we can finally reach the high quality end products for different 4 case studies. First of all, we would have pharmaceutical industry, then ammonia preparation, then fertilizers, and finally polymer industry. So in this sense, to reach this objective, NeoCycle will involve, as I mentioned, all the relevant actors in the value chain, from, for example, public authorities to recycling companies, technology developers associations, NGOs, and commercial companies, for example. So everyone is framed into this project. The main objectives, the main aims of NeoCycle in this sense are these 3. First one, demonstrated at TRL6, the technical feasibility of these secondary neodymium iron boron magnets upcycling. Then demonstrate these processes we are studying, we are working in, are circular and sustainable for the upcycling concept of the magnets. And finally, developing an upcycling process that can reach, of course, the market, which is a very competitive place for this topic, and, being also socially accepted, economically available, and inclusive and democratic, and building in collaboration and in cooperation with all the stakeholders. So in this sense, this is a general scheme of all the processes. I mean, so general, of course, we would need to go much more in detail, but just to have a preliminary idea of how the technical work works here, we would start by our raw materials. In this case are already spent magnets. These are extracted from the hard disk drives, and then after the recovery of these magnets, these are suffering 2 different processes or technologies to extract the part that we are interested in magnets. So we would have, on the one side, a solid state chlorination, and then an electrochemical approach. And both paths are available to extract boron, iron, and neodymium selectively and separately. So once we have them, the main objective of the project would be to transform them into high value end products, as I mentioned before, to end in different industrial sectors, such as the chemical industry, fertilizers, hydrogen economy, or pharmaceuticals with APIs and all that. So, regarding the timeline of the project, as I mentioned, we started on September last year, September 2024, and then during our first year of lifetime, we achieved one of the most important milestones here, which is the obtention of the first samples of boron, iron, and neodymium. They are being sent within the partners, so we can go to further steps in the project. Then for February next year, we are expecting to update and to generate some protocols to optimize the upscaling of the separated recovery of neodymium iron and boron. And after that, I mean, being actually closer to the end of the project, we would have the demonstration of the upcycling approaches with the recycled elements, and finally, of course, the completion of the sustainability assessments. This would be the structure, the general structure in work packages, divided in work packages of our project. So we would have, of course, the first three work packages dedicated to project coordination and management. Then we would have a fourth work package dedicated to the fine-tuning of the recovery of neodymium, iron, and boron. And after that, we would go to work package 5, which is more focused on the process of scaling to recover separately these elements. After that, we would have work package 6, which is about the upcycling approaches of neodymium, iron, and boron. And in this sense, we would also support all these activities in work package 4 and 5 overall, in work package 7 with the digitalization of processes. So in this sense, we would actually develop some digital twin tools and some mathematical models to support all the processes we are carrying out experimentally. Then we would also have work package 8, which is about product quality and performance validation of the end users. That's where the final products will be developed and tested. So we can check our cycle is complete. And after that, we would have work package 9 and 10, which are more focused on the preliminary and also the more advanced sustainability assessments, and also regulatory considerations and regulatory gaps, and some different studies in that sense. And finally, of course, but of course never less important, we have the three last work packages dedicated to communication, dissemination, and exploitation activities. So, in this sense, the main activities of NeoCycle project will be these 6, but, whoa, sorry. Okay. Yeah, almost, yeah. Sorry. So we would have, for example, the demonstration of the solid state chlorination and also the electrochemical and purification processes to this TRL to TRL6 to separate the 3 different elements we are focusing, we are targeting in NeoCycle project. Then the demonstration of the upcycling approaches for neodymium, iron, and boron by developing industrial catalysts. Then the validation of the quality and also the performance of the final products by, of course, commercial companies within our consortium. Then we would have the processes digitalization, as I mentioned, mathematical modeling, digital twin tools, development, etc., to support all this experimental work. Then we would have the sustainability assessment. Within them we can find the life cycle assessment, social life cycle assessment, the life cycle costing, and so on. And also, for example, the risk assessment and techno-economic assessment. So we could be sure that the activities in NeoCycle are not only sustainable, but also economically available and socially accepted. And finally, we pave, of course, the way to the market of all these products we are preparing, we are targeting in NeoCycle project. So, of course, within this activity, we can find some sub-activities like the assessment of the legislation, the standardization roadmap development, and then the plan of communication, dissemination, exploitation, as I mentioned. And of course, within there are the participation and organization of at least 13 stakeholder engagement events, like this one. and then the creation of business models for all the cares included in this project, and finally the development of different training courses targeting soft and technical skills, and also the promotion of the generation and creation of new jobs, and also to reduce the gender gaps. So, in this sense, the main expected results of the project would be, of course, as I mentioned, the solid-state chlorination and selective electrochemical neodymium extraction methodologies, then the development of catalysts based on neodymium for APIs and polymer preparation, and also iron and iron neodymium catalyst for different projects such as the green ammonia and APIs the preparation, and also the ammonia synthesis and the composition reaction. And then, of course, another result that we are expecting from the experimental point of view is the development of 2 fertilizer products based on this recycled ammonia. So that will be all from my side, at least. Thanks again, all of you, for being here. And please, I hope this event is very fruitful and we can have very interesting discussions about this. And I would like also to thank again to the Very Sustainable Mining Clustering for the efforts organizing this. So thank you all, and please be very welcome.
Now we have Dr. Peter Froelich. He is online and he is going to tell us about REE recycling and metals extraction. Peter? Okay.
I can hear you, all of the others. So I asked for the rights for the access. Share my screen. So I hope you can see my screen now. Alicia?
Yes, we can see it, Peter.
Okay.
Could you please put the full screen mode so we can see it perfectly? Yeah, fantastic. Thank you.
Oh yeah, thanks. Yeah, hello also from my side. And also thank you for the opportunity to give this presentation via this format, via online. So, and also thanks to Alicia, Clara, Macarena and Maria for organizing this very perfectly organized as ever. So most of you I met the 1st of October in Pavia, but also welcome to the stakeholders and also of the other partners here in the audience. Yes, as Macarena said, I will like to introduce you the work package for the major objectives and also some of the results which might be interesting for you. So the package, it's one of the largest working packages of the NeoCycle project. First, we start with the inventory. That means to see what kind of magnets do we have and how to collect these magnets and who will prepare or pre-treat these magnets. This was done in the first part. Then we have this technological part, some innovative technologies we developed and scale up, like the solid-state chlorination as mentioned and the electrochemical extraction. The next will be the separation of these valuable elements, not only of the rare earth elements, also of the other ones I will show you in some minutes. And then the last part is to evaluate the the impurities and other elements and
Yeah. I was expecting he finishing. Peter, we cannot see your screen accordingly. Please, could you please push the button again of the full screen because it's not working.
Oh, sorry.
Yeah.
Yeah, it's the problem sometimes with the online form. It's now better?
No, you have to go to the right corner, the bottom corner on the right. Yeah,
Yes.
that one. Let's see if now it's working. Your computer is thinking. No. Yeah, now it's perfect. But yeah.
Okay. I hope this will remain so in this. It's okay?
No, you have to change again the presenter mode, actually. Yeah.
But there are no other possibilities for me to say here. Present.
Let's see. Yeah, in the header you have the option to do it. It's written in Deutsch, so I cannot really relate if it's that one. But yeah, because now we are seeing your screen as a presenter mode. Yeah, so let's see. I apologize for the technical inconveniences.
Otherwise,
It's the third option. It's the third option in the header that you have on your
Peter,
left.
up in the header, you have the one or second or third
one.
option. No, don't change.
No, where you were
No,
with the full screen, yeah.
yes.
full screen. Go to full screen.
And then presentation.
The third one.
Maybe,
The other one.
yeah.
Third one.
No. I think. Wait. I will come closer because it's too small to see what is. Was steht's there? Yeah. Try the third one. Bildschirm presentation 9. Not the third one because
This
there's
is
and
finishing. This is finishing now.
Yeah, click on it.
Yeah.
On the third one, click
Yeah.
on it.
No, the
please.
second. That's okay.
The second
Scroll
one.
down. Yeah. Click on that.
Change.
Yeah.
That
Now
now it's
better?
perfect. Thank you very
Jetzt
much.
geht's.
Thank you
Oh,
both,
so-
Peters.
So I'm
Yes, good
sorry.
shot.
Yeah, Peter. Thanks to Peter. Okay, yeah, that's the problem with the techniques. So, okay, but let's come back to the technology part. What is the state of the art of the magnet recycling? So actually, we can distinguish between two routes. This is the mechanical recycling and the pyrometallurgical way. You can see here. The mechanical way, you use the material you receive, like the magnets, from different sources, not only from the HDDs, like Macarena mentioned. First, they are dismantled, and then you can reuse the complete magnet without doing anything. This is I think the best way, but it's not suitable for all of them. You need no grinding, leaching, or anything else, but it is difficult, and you can't handle and do it with all the magnets. And also it's not usable for damaged or corroded magnets, and also for the small HDDs magnets, you will see. So, and then on the right side, you see the pyrometallurgical recycling. So the first step is the same like we do in NeoCycle. The magnets are grounded to receive a fine powder, and then the powder is used directly as the starting of the input material to produce new magnets, without leaching or anything else. But this is not possible if you have any contaminants in the magnets, or especially for the rare earth. They will go into the slag. This is the last of the elements. So we need some new ways to think new ways, and that's what we do in the NeoCycle. I call it the NeoCycle toolbox. It's very simple here to say on the left side we have a kind of technologies, and then we are producing some or we decompose the magnets by the chemical processes into their elements or into mixtures or to produce intermediates or directly to products. And then they are transformed, or they can be transformed into other products like the magnets. It's the recycling. Another way is to produce intermediates for pharmaceuticals. This is also one part. So in NeoCycle, we do not look only into the rare earths and reuse of rare earths, also to use the material themselves and also the other constituents. So, and then overall we have this assessment of the technology of this chain. So at the beginning we start with the collection of the material. We have two partners, one in Greece and one in Italy, Icarus and Stina. They collected different magnets you can see here on this slide from laptops, desktops, server materials. They look very similar. And we received actually about 200 kilograms of these materials. It's a large amount we collected already. The materials in the HDDs are dismantled, disassembled in the first steps. So you extract the kind of this casing. This is the metal with the magnet. And after putting it into the oven, the magnets are demagnetized, so they have no magnetic properties anymore. And then you receive both streams, the casings you see on the top here, and here we have these magnets. They look a little bit colorful. We have different colors. It comes from this thermal treatment process, and you can see also here there are some detachments of the nickel from the surface. So we have a large variety of magnets. Some are they have nickel on the surface, some without any coatings. So it's a challenge, but we do it. So in the next step will be the crushing and milling. And after this, we do the analysis. That's what chemists do. You can see here in this diagram the chemical composition. Most the highest the iron is the major component with between 65 and 70%. Then you have neodymium. This is the rare earths, the second one here, and the colors is from the different sources like servers, laptop, desktops, and also the coatings. So we have iron, neodymium, praseodymium. It's also one very valuable rare earth element inside the magnets. Boron. Boron is sometimes in a discussion it's missing or doesn't mention it's not mentioned, but for us it's very important to have bore and to determine the amount. And as said, during the thermal treatment we receive such a coating, such a nickel coating. It's very interesting, and it's consists nearly complete of nickel. So, what are our two innovative chemical leaching technologies in NeoCycle? We have on the one hand the solid state chlorination, and on the right side the selective electrochemical neodymium extraction. The processes are developed by the University of Freiberg with two different working groups. So let's see on the left side, what is the solid state chlorination? It's a process, a dry process without using aqueous acids. We are using ammonium chloride. It's a chemical, and this chemical is mixed with the milled magnets, and at a temperature above 290 or 300 degrees Celsius, it decomposes. It decomposes into hydrochloric acid. You can see here in the formula for the chemically interested audience, and you see hydrochloric acid as a gas, not as a liquid, and ammonia. And these hydrochloric acid reacts then with the rare earth elements and also with the iron from the magnets. On the other side, you have this electrochemical way. They are in parallel. We do it in parallel. It's using electrical power to oxidize the magnets as an anode directly to dissolve all the elements like iron and neodymium to produce neodymium and iron into in the solution as ions. So for the solid state chlorination, I will show you both ways now. The solid state chlorination, we performed the experiments at the moment in lab scale. This means in the grams, we use some grams, 100 to 200 grams, batch-wise. This is an oven. It's called a rotary kiln technology. The ammonium chloride is mixed with the magnets, with the powders in this picture here, and then it's heated up. It reacts to form iron and neodymium chloride, and then these chlorides are leached with water, and the separation of the elements. This is part of our of the other partners like Fraunhofer, Loredera, and the University of Pavia and Barcelona. So the second one is the electrochemical neodymium extraction. I only showed it a very short way that you can understand it. What was the extraction? You see, we put in the magnet directly into the leaching solution, and we use some special leaching agents like deep eutectic solvents. These are special solvents, not only the aqueous system, with some advantages and also disadvantages, with the aim to dissolve the neodymium. You see here the neodymium is extracted into the phase, and the iron phase or the rest shall remain in the residue. So what are deep eutectic solvents? This is a mixture of different organic compounds. Mostly you have an chloride or halide salts, and then you have an hydrogen donor, it's chemical like here urea, and they are mixed. And by doing this, you are changing the properties, so you can dissolve elements over a broader electrochemical range compared to the typical leaching in the aqueous and water system. So, but we observed only a very low dissolution rates here because of the passivation behavior of the magnets. So we changed the systems, we changed the ratios between the deep eutectic solvents and the aqueous system, and this leads to such a more non-selective electrochemical dissolution approach. Yeah, you can see here, this is the experimental setup. This is the anode, this is the magnet from the first pictures. You see here some kind of corrosion or it's dissoluted. These are the different electrodes. And the iron and neodymium, they are extracted, they are dissolved, and then they precipitate during this step. So there are some more than one step in one. So to extract the elements, and then they are separated and purified in further steps by our partners. So, okay. The first flow sheet, maybe that's interesting for you. It's what is the actual state. We have here the magnets collected around the European Union by our partners. They are demagnetized and then used by the electrochemical way to produce the iron. Iron hydroxide and neodymium oxalates, and then you have the solid state chlorination producing the chlorides from iron and neodymium as solids, and we receive the ammonia. So it's very important because ammonia is an important product for the fertilizer industry for our partners. So, and then this in this gray, the next steps in gray will be done by our partners. So the results, to sum it up, the solid state chlorination is a process which exhibits a larger or higher concentration of hydrochloric acid compared to the hydrochloric acid in the liquid solution. This is the difference why we choose this way and not the typical chemical leaching via acids. So we received a very high conversion rate of the iron and rare earths into their chlorides, and the ammonium chloride is nearly completely converted and decomposed into the hydrochloric acid and ammonia, so we can collect or absorb the ammonia, and on the other hand our products, the chlorides. And this is done in a rotary kiln. It's important. This is a scalable reactor. It's important for the next working packages. And so it's easier for us to scale this into larger scale. So the electrochemical way, we received the boron into solution. It was very complex and also difficult to analyze, but it was possible to extract boron neodymium via this electrochemical way. But we need some more experiments to change the parameters to optimize this way to higher selectivity. So this is also the next, will be the next steps, the optimization, improvement, the characterization of the products, and also to get in contact with customers for these products, and to complete the mass balance for the entire value chain of our process units. So then I have some points to get in contact with you, with the stakeholders, and also with some further alignments. So I've divided it into 3 different levels: technical level, business, and social level or societal level. So for us, it's important to get in contact with magnet producers, distributors, also recycling centers, to get a deeper view into this market, into the structures. For us, it's also important to know companies who can supply a special process or reactor equipment. Same like engineering companies doing the engineering for a larger plant. This is the business level in the middle of the slide, who could be such a plant operator using our technology, our platform. And for me, it's also important to get more information about the chemical industry, about ways to sell the products we have here in the NEO cycle. So, and then the last one, we have this this social level this means for me publication of our results,
Peter,
dissemination, and to give time technical
Peter.
interviews. So thank you very much. Yeah.
Thank you.
Yes, thank you. Oh, Maria, I can
The
understand you. Yeah?
The following ponent is Dr. Herbert Ronduda, who are going to tell us about upcycling of iron, neodymium, and boron.
Okay, good morning, everyone. Thank you very much for the introduction, and big also thanks for the organizers for making this event here in Seville. It's a pleasure to be here, and let me introduce the work package 6. So the aim overall of the project is to upcycle the key elements recovered through the spent magnets, iron, neodymium, and boron, and upcycle them to the several key industries for pharmaceutical industry, nitrogen industry, as well as polymerization. And these key elements will be used in the crucial sectors, pharmaceutical industry, ammonia synthesis, as well as in polymerization. As for example, iron nanoparticles will be used both in ammonia synthesis catalyst production and also in the production of API. In the case of boron, it will be used in the active pharmaceutical ingredients production, whereas neodymium will be used in all these branches, pharmaceutical industry, ammonia synthesis catalyst production, as well as in the polymerization. And different partners have different tasks, and for example, the work package 6 leader, University di Pavia, aims at developing the catalyst for the API synthesis, whereas the role of the Warsaw University of Technology is to develop the ammonia synthesis catalyst for fertilizer production. And our aim is to use iron as the active phase and neodymium both as a support material as well as a promoter. And our task is dedicated to obtaining two kinds of the catalyst. The supported one catalyst and also the inverse catalyst, also called in the literature as a bulk type catalyst. And regarding the supported type catalyst, iron nanoparticles are deposited over the neodymium oxide, whereas for the inverse catalyst, iron nanoparticles act somehow as a support from the promoters. And in the case of inverse catalyst, the metal content normally exceeded 50%, whereas in the case of support catalyst, it's about 10–20%. And we decided to use first the commercially available salts to optimize the catalyst formula and catalyst synthesis method. And after obtaining the final catalyst procedure, we'll use the salts from the recovered e-waste to assess if the catalyst obtained from the recycled salts can be as good as the catalyst obtained from the commercially available salts of the high purity. And some key stages during this catalyst development includes, for the supported type catalyst, optimization of the neodymium oxide preparation, then active phase deposition selecting a proper method, and also optimization of active phase loading, also selection of the promoters. And for the inverse catalyst, the very important step is to determine the optimal neodymium to iron ratio as well as co-precipitation condition. And after that, we also select some other promoters to best boost further the activity of the catalyst. And let me start with some preliminary results regarding the supported type catalyst for ammonia synthesis. So firstly, our efforts were dedicated to the supported type catalyst in which iron, cobalt, or nickel was used as the active phase. And when depositing iron or cobalt over the neodymium oxide, high efficiency catalyst can be obtained, whereas nickel catalyst showed almost no activity in ammonia synthesis. Cobalt catalyst received the highest ammonia formation rate, whereas for the iron catalyst, the highest intrinsic reaction rate, meaning activity per active sites, were obtained. However, during the catalyst operation, iron catalyst operation, some serious issues occurred regarding the iron nanoparticle stability. So regarding this stability, we aim at improving its stability by involving some strategies. And for example, alloying iron with cobalt, adding other promoters, or modifying the synthesis procedure. So the idea is to stabilize iron nanoparticles under high temperature conditions. And firstly, we have decided to use alloying iron with cobalt. And why is that? There are two reasons behind that. Firstly, the DFT calculations. And in the literature, you can find that adding a small amount of cobalt to the iron catalyst can be beneficial in terms of its performance. And this is because it improved the nitrogen dissociation, the rate determined step of ammonia synthesis. And the second reason for selecting cobalt as a dopant is that in the spent magnets, there is about 2% of the cobalt. And that is why it is worth investigating the effect of cobalt doping on the iron catalyst performance in ammonia synthesis. So we prepared several catalysts using the vapor impregnation method, in which the total metal content was about 10%. And as a cobalt content, we use 1, 3, and 5%. And as you can observe, adding a small amount of cobalt improved the catalyst performance. And for the catalyst containing about 5% of cobalt, the activity was comparable to that containing only pure cobalt. And that beneficial effect is related to the several factors, including improvement in the catalyst texture, but also improvement in the chemisorption properties. So cobalt addition improved the chemisorption properties of iron active sites by generating new active sites and also increasing its number. And regarding the studies on the inverse catalyst, the very first aim was to optimize the ratio between iron and neodymium. And we obtained several catalysts using the co-precipitation method. And we used the catalyst in which iron content varied from 50 to 90%. And importantly, in the magnets, spent magnets, the ratio of iron to neodymium is about 70 to 30. And that is why important to study the catalyst compositions close to that in the spent magnets. And actually you obtain very interesting and satisfactory results because all the catalysts were of high activity. The highest activity in terms of reaction rate was noted for the catalyst containing about 80% of iron. And this beneficial effect was connected with several facts. The first one is the improvement in the textural properties. The surface area improved as optimal neodymium oxide content was determined, but also there were an improvement in the reducibility of iron oxides during the catalyst activation, and also an improvement in the chemisorption properties of the active sites. So again, neodymium neoptimal content improved the number of active sites, and the active sites were more diverse in nature. But the very interesting observation is when we compare the activity of the optimal catalyst with the industrial one. So under similar reaction conditions, the developed catalyst outperformed the industrial iron catalyst, highlighting its prospects for further development. And during Further steps will still be optimizing the catalyst composition and catalyst formula, because there is still a place for improvement. Because there are still place for improvement in terms of promoters, dumping, which can give satisfactory results. And after obtaining the final catalyst composition, we'll prepare the catalyst using the recycled salts to assess its performance compared to the catalyst obtained by commercial salts. And the very final step after the getting final composition will be to test the catalyst in different conditions. So we'll perform the kinetic measurements in different temperatures, pressures, and feed gas composition. For example, we aim to add ammonia into the feed gas to assess its real performance under operational conditions in the real ammonia synthesis reactor. And also we'll be cooperating with industrial partner Casale regarding the catalyst testing, modeling, and also techno-economic analysis to assess its prospect for industrial implementation. And that is all for me. Thank you very much.
The following speaker is Dr. Felix Freita, and his presentation is about digital product passport.
Hello, good morning. I am making this presentation about task of work package 9, the digital product passport. We are working together with Fraunhofer, Austria on this task. So I'm from the UPC, the Technical University of Catalonia, and we did prepare the presentation together with Fraunhofer. So I want to talk about our methodology and where we are and what are our next steps. And this also allows me to talk about the situation of the DPP in Europe and globally. So, well, actually this picture came already a few times, it's also here. And so we have this simplified picture of NeoCycle. And from my perspective, we can see that these hard disks potentially could have a DPP, a description about the many details of the hard disks. And once these materials are recovered, potentially these materials also could have a DPP, a kind of, sometimes they call it material passport. Today, the DPP is not there, but we will see if in the next years this will become available. So maybe this is the connection. So DPP potentially for hard disks and DPP for materials. So I want to talk about a few aspects of the DPP. The first is the regulation, what is there. So in Europe, there's the ESPR, the Eco Design for Sustainable Products Regulation from 2024 that introduced the DPP at a high level with some directions how these DPPs should look like. So it's a first like a regulation about DPPs which should be extended with so-called delegated acts about specific sectors. This is not there yet. So we have, at the moment, we have this generic description or regulation on the DPP from the ESPR. And then also, there's this Critical Raw Material Act that seems to recognize the importance of recovery of materials. And the DPP is for circularity, and also there's this recovery of materials. So there can be a relation between the ESPR and this Critical Raw Material Act to improve recovery and circularity of products. Next dimension is what is the standardization situation. So there are different efforts around. In Europe, there is one effort is with European projects that try to build pilots to show initial DPP systems, how they could look like. So I think the most well-known is SIRPAS 2. It's ongoing, and they have several DPP pilots to be developed. I think they will finalize in 2027. So at the moment, they are rather more in the initial part of the project. So we have the approach of Europe, try with European project DPP systems, and they also have, the European Commission also has requested standardization of DPP system to the European standardization body, the CENELEC. And so they have a working group or a joint technical committee, the JTC 24, that should come with the standards. And this should happen by the end of this year. We will see if they make it in time. So in Europe, we have like this. Standards are not there, but they're working on it. And they should come out soon. And globally, there are also initiatives about DPP. So the ITU has published 2 recommendations about the DPP. It's mainly about the DPP model, not about the DPP system. And the UNECE also works on a DPP system that is known as an UNTP DPP. So this is also around, and the other standards are technical standards to build the system, because the DPP system has many ingredients, so there are technical standards that are also relevant for building the system. Okay, so this is so we have the regulation. ESPR gives a high overview of the DPP. We have the standards. Things are coming up, but they are not there. And what is the DPP itself? There's a definition from SIRPAS. They say it's a structured collection of product-related machine-readable data. So sometimes the people split the DPP in 2 parts. One part is the data part, which just is what is the content of the DPP, what is explained about a product or material. Does the DPP contain environmental information, origin of the product, and what is there, what is inside the DPP? That is the data model. And this is one part, and the other part is how to build a DPP system technically. It will be a distributed system that should be scalable, easy to use, and so on. So DPP system is the other part. And when people talk about the DPP, we can know from the context if they talk about the DPP model or the DPP system. And CENELEC, I mentioned before, for instance, is trying to prepare the standard for the DPP system, for the technical implementation. So today, we don't have them. And with this slide, I want to relate the UNTP DPP with the European DPP. So the European is the one that is explained in the ESPR. So the European DPP is starting from the product when it comes into the market, and it targets circularity. So reuse, recycling, how this can be tracked and described for products. While the UNTP starts much earlier, it's now hard to see, but it starts with the raw materials. So the UNTP they are not so interested in circularity. It's more for business interaction. And the UNDP is more business-driven. It's not a regulation from the top. So they want to improve supply chain interactions with their DPP, while the European one is more on recycling, on circularity. But, well, they should meet once the product is finished and comes into the market. So they should be compatible, they say. And now, how do we address this situation in the project? Well, one part is to look at the evolution of the regulation of the standards and prototypes, how people build them. At the moment, you can build it as you like because there are no standards available. So this is one part, to follow this. And then the UNDP is more public. The UNDP players share materials, share code, share data models. So we are more aligned with the UNDP DPP because there's more public information around than with the European. So we are looking at the UNDP DPP more for practical implementation. And another direction of our work that is more Fraunhofer work is to conduct interviews and talk with, I think, companies from Neocycle and other companies. They know what are the expectations for the data model of the DPP. And hopefully we get at least real requirements from the partners in the project. And they do these interviews. What we have done, for instance, we aligned with the UNDP DPP, so we have extended their data model to represent a computer with a hard disk and with neodymium, so kind of data model that has the materials and this component inside. This is one approach, and manage this DPP with a technical system. That is what we are doing. And currently also these interviews are ongoing. And finally, the next steps. So we want to continue implementing rather the UNDP DPP. There are other elements that we have not addressed yet. The traceability events to describe transactions that we think we want to do this. And also we have made a contribution to the ITU, to the study Group 20, which is more on the technical part, technical aspects. So maybe it will be possible with a new work item that seems to be accepted to contribute to standardization of requirements and technical architecture within the ITU. And yes, maybe, well, this picture is from the UNDP DPP, so actually they are really starting with a material passport from the beginning. So it's probably more aligned with Neocycle than the European DPP that is starting with a product. Okay, that is all. Thank you for your attention.
Now, with the goal of explaining the techno-economic viability of Neocycle and products, we have three speakers: Alberto Garbullo, Beatrice Trucci, and Leonardo Bracetti. The first one is Alberto Garbullo.
Okay, so let's start to talk about green ammonia. Okay. So, just to give you an idea, what is the role of Casale within the New Cycle project? As already mentioned before, Casale goal is to validate the green ammonia synthesis catalyst that will be developed within the work package number 6 in order to test it for the synthesis of green ammonia for supporting the hydrogen economy. For those who doesn't know Casale, Casale is a Swiss engineering company that started at the beginning of last century with Luigi Casale, who developed a process which was different from Haber-Bosch, allowing to work at higher pressure and giving some benefits. But one thing that most of the people doesn't know is that at the early of last centuries, Casale also started to work on green ammonia by developing and patenting processes for green ammonia. So this gives us the idea that Casale wants to be always on the sustainable path. But let's move on green ammonia. Why green ammonia matters in the decarbonization? We already talked about ammonia. We know that there are some benefits, but the most easy ones to understand is that ammonia is a molecule that does not contain carbon. So it does not provide a direct emission of carbon dioxide. And there are already plenty of applications for ammonia that can help to decarbonize this field. Well, first of all, green fertilizers. Ammonia is used, 70% of all the ammonia produced goes to fertilizers. So there is a high request of fertilizers. If the ammonia will become an energy vector, as many people are trying to push, ammonia could be a hydrogen carrier or could be used directly as a fuel for industry and shipping. And of course, there are plenty of applications in the chemical industry in which ammonia finds place. But probably the most important aspect of ammonia and green ammonia is that there are already commercially available infrastructure that are used to spread and use ammonia without investing additional money. But to give the feeling of reality, what are the numbers behind ammonia? Well, the total ammonia market estimated for this year is around 85 billion of US dollar, and is expected to grow by 10% within the next 5 years, especially due to the high request of fertilizers, but also the possible expansion in the energy sector. But what's about green ammonia? Well, today there is not clear picture of what is the existing market from green ammonia. However, many reports, many work are forecasting that by 2030 there will probably be a market of $6 billion US on green ammonia. And this is mainly driven by the drop of price of electricity, decarbonization, and the needs of green fertilizers. And to give you an example of when I'm talking about green market, well, currently there is under construction and will be start next year a pilot in Minnesota in US which use Casale technology that is able to produce 1 ton of green ammonia per day. And this gives you the feeling how much is the value of the ammonia. But what are the key challenges for green ammonia? Well, there are plenty of them, but probably the most important and key are the high energy demands and cost of electrolysis that are costing almost 90% of levelized cost of ammonia, so the electricity. The fluctuation of the green energy that induce high capital cost on the ammonia synthesis plant. limits on current catalyst technology, so there is the need to develop new and advanced catalyst that is able to accommodate this, and of course low awareness about this aspect. But of course this is something that with this kind of workshop and the communication the people are trying to solve. So what is the cost of green ammonia? Well, the estimated levelized cost of green ammonia today, based on several reports and our analysis, is between 600 and 1,000 euro per ton of green ammonia. This is based on the energy input and the size of the plant. But if you see what is the value of green ammonia today, the blue bar, and comparing with the gray ammonia, the one that is nowadays produced, you see that gray ammonia costs between 2 and 3 times less than green ammonia. And this is for the aspect that we just mentioned, so electrolyzers and the cost of electricity. However, all the projection of the cost about electrolyzers and electricity forecast that this cost will largely decrease in the next decades. And as you can see, the forecast for 2014 is that green ammonia will not beat the gray ammonia, of course, but will have a comparable value in terms of cost. So the green ammonia will stay still expensive, but the gap is closing. And why is happening this? Well, green energy provide a very flexible input, and this induces high cost on the process. The process must be dynamic, inducing a lot of cost in order to accommodate this energy input. But there are already processes like the one that Casale is commercializing, in which by using existing catalysts it's possible to tune the capability of the process between 16 and 100% and combine with electrolysis and nitrogen generation from air separation unit, allowing to use now green, with existing technology, to produce now green ammonia. There are still some gaps that must be filled before going to have a full commercialization of green ammonia. First of all, as mentioned, electricity and electrolyzers. That is probably the most impactful parameters that affect the cost of green ammonia. There is the need of high efficiency and scalable electrolyzers. There is a lot of need of improvement of the processes in order to accommodate the fluctuation of green and power input coming from green electricity. Digital twin. With all these parameters that change during time, there is the need of new modeling, advanced modeling that are able to take the input, make the process work as the best of their the capability, and give the output based on the market's needs, which will largely affect the cost of levelized cost. There is the need of high flexibility, ramping up and down without degrading the catalyst, which is one of the key parameters and heart of the process, and of course, high catalyst that can work at high temperature and pressure, but also at low pressure and temperature in order to meet the requirement of the process. So I hope that with this very quick marathon, I give you the idea that green ammonia has a possibility for the future. There is a clear trajectory that there is viability, economic viability for the production of ammonia. There are already a wide range of applications, and this would help the decarbonization of our society. The market is going to increase. There is the need and the request of this product. The technology has been technically proven because there are already pilot planned in relevant industrial scale that can demonstrate the feasibility. Of course, there are several gaps that needs to be solved, but this is part of the activity. So the final takeaway message is that green ammonia is not only sustainable, it will be also economical in the next years. And with this, I thank you for your attention.
The second presentation is Dr. Beatrice Trucchi.
Okay. First of all, good morning everybody, and thanks to the organizer to have given me the opportunity to better explain Flammarole, that is my company, in the New Cycle project, as well as the purpose of sustainability goals within this project. So, okay. Before starting, I would like to give you a short overview regarding our company. We are a pharmaceutical company. The headquarters of our company is based in Italy, but we have 5 sites worldwide, 3 in Italy, 1 in China, and 1 in USA. And we are currently more than 900 employees, with a revenue in 2024 of 243 million. As I just said, we have an Italian private company founded by Dr. Marco Negrisoli in 1950, and we have acquired up to now different sites, starting from China in 2005, in Malvern site in 2019, recently in 2022 Bulciago site, another site in Italy, and we have just opening and increasing our capacity in China again. Okay. Basically, our capabilities ranges from kgs scale in Malvern as well as in Nongkai in China, till commercial production, more than 100 million tons in Bulciago site, based in Italy, as well as in Nongkai. But which are our main products and expertise? As I just said, we have a pharmaceutical company, we are a CDMO, and our goal is the synthesis of pharmaceutical. Okay, okay, perfect. And we produce pharmaceutical intermediate as well as API. Our synthesis is based on the chemical diversity applied to amino acid structure, and this diversity is related to the functionalization of amine as well as carboxyl group, as well as the introduction of different protecting group. We can achieve such goals thanks to the application of organometallic transition metal catalyst, the possibility to use cryogenic condition, as well as the possibility to explore different technologies, such as, for instance, biocatalysts, as well as hydrogenation and continuous flow at lab scale as well as at industrial scale. The core of our company, and this is very important in order to better understand our role in sustainability, is R&D. We are currently more than 150 people worldwide, and we apply artificial intelligence not only at the process scale, but also for the analytical development, thanks to the application of quality by design, as well as the design of experiments. Which is our main goals in terms of sustainability. We have received this year a bronze award in EcoVadis report. And as you can see here, there are different areas that need to be further improvement. And so keeping into consideration the well-known 17 Sustainable Development Goals that have been published by United Nations in 2015, we consider in 4 areas of sustainability improvement, divided in governance and mission, people and community, environment and innovation, and finally supply chain. Regarding governance and reporting, basically during next years, we would like to improve our KPI dashboard, the possibility to well organize every sustainability area and KPIs in annual sustainability report, and regarding the people and the community, we address our efforts in order to continue the development of an environmental sustainable governance team, as well as the continual professional development of internal innovation agents, thus adhering to the 3 and the 4 goals of the just mentioned sustainability goals. Regarding qualification and evaluation management in terms of supply chain, and this is very important considering our role in New Cycle project, we adhere to the 12 sustainability goals thanks to well comprehension and the development of a sustainable procurement management, considering all raw material that are needed in our process. No? Okay. Finally, regarding environment and innovation and energy consumption, we have addressed our efforts regarding all the action that needs to be in place for scope 1 and 2, as well as scope 3. Particularly, we will try to reduce our energy consumption. We address our effort in regular reporting and monitoring energy saving projects. And regarding scope 3, our company will be put in place some incentives for employees to reduce emission due to community with carpooling. Now I would like to show you our role in the Cycle project, and particularly the sustainable goals that we can achieve considering the Cycle project. We have already talked about the main aim of No Cycle project, that is boosting the circularity of the waste chain of neodymium and boron-based permanent magnets, and our main roles in terms of upcycle of this material will be addressed starting from 2027 till the end of the project. Basically, we are involved in the use of neodymium and boron for the synthesis of intermediates, pharmaceutical intermediate, and the final API. And I would like to show you which kind of API we will produce. our activity is strictly related to the activity of University of Pavia that will provide us the synthetic protocol to be scaled up on large scale. Okay. So we will work on working page 8, but as I just mentioned, our activities is related to working packaging 6, whose leader is University of Pavia, that is strictly related to other working packages as my colleagues have just summarized. We have subdivided our activities in different tasks. Task 8.1 that is addressed to the synthesis via neodymium catalyst of prostaglandin, as I will explain later, as well as task 8.3 that is addressed to the synthesis of a particular class of API, the TNIP class, thanks to the application of boron catalyst. All these two tasks are subdivided in other activity, basically the technology transfer, starting from the protocol that University of Pavia will transfer us, the process optimization in order to scale up the process on large scale. Regarding the first task, that is the synthesis of intermediate thanks to the application of neodymium catalyst, the final goal of our activity will be the production of a representative 100 gram scale of the coral lactone that is a key intermediate for the synthesis of PGI. The prostaglandin are present in our body and are related to different targets. Thus, they are involved in different pathways: cardiovascular, gastrointestinal, respiratory, and gynecological fields. As I just mentioned, the key intermediate for the synthesis of PGI is the coral lactone. As we are involving in the upcycle of these elements, so it's very important to highlight the value of this kind of molecules. First of all, the PGI have a market size that is 31 in 2021 and is expected to be around 50 billion by 2026. They are particularly used in the treatment of glaucoma. I here mention some examples, like for instance, latanoprost, trafoprost, bimatroprost, and tafluprost. Basically, they are a modest sales volume ranging from 0.426 kgs per year in Europe, but they have a consistent turnover which range from 278 of tafluprost millions of USD per year of tafluprost up to 1,280 millions of USD per year of bimatroprost. Another important point in order to better understand the high value of such molecules is the main aim in terms of reshoring. Especially during the COVID period, the necessity to build a European resilient supply chain as alternative to the East market is becoming more and more important. And we need to address our efforts in order to be competitive in terms of quality as well as production. I don't want to enter into details of the different synthetic steps that we will overcome, but just to point it out that we need to convert the intermediate 2 that the University of Pavia will provide us into the core lactone, that is the intermediate 6 here, thanks to the application of a protocol that consists in basically 4 steps of synthesis. The synthesis of intermediate 2 will be performed by University of Pavia, employing the neodymium as a replacement of magnesium perchloride here. That needs to be tested, and this is the challenge of this project. And we need from our side to keep into consideration the commercial availability of the ligand that this step require. For sure, you can see here that there are different reagent and solvent that need to be replaced, and this will be our challenge in order to make the process more sustainable and feasible on large scale. Okay. Regarding the task 8.3, that is the synthesis of API thanks to Barum catalyst. In that case, our deliverable will be the production of a representative 100-gram scale of a class API belonging to the class of TNIB, thanks to the application of Suzuki-Miurawa reaction. Again, I would like to point it out the great importance of this class of API in terms of market size, around 45 billion of USD. But in that case, even if the market size is very, very interesting, the volume could range from 10 kgs up to 500 kgs. And again, also in this case, it could be very important in the scope of reshoring. Before explaining to you the role of TNIB class of API, I would like to focus on the synthesis. In that case, University of Pavia will provide us the key intermediate boron derivatives that I here reported, and we will use this intermediate to achieve the synthesis of the final TNIB class. I reported here the synthesis of TNIB. This is one of the potential API we will synthesize, but eventually we can explore this kind of synthesis and this reaction on other API belonging to this class. The TNIB class are very important because they act on a different kind of tyrosine kinase that is enzyme, receptor that is involved in different kind of disease, particularly in tumors as well as in autoimmune disease. I here report some example of this class of drugs, and what I would like to point it out here is, first of all, the therapeutic indication. I just mentioned tumor, solid tumor, like for instance blood cancer. You can see here that is the therapeutic indication of crizotinib, but also some autoimmune disease, like for instance rheumatoid arthritis. Another point that I just mentioned, but here I would like to highlight again, is the worldwide consumption that could be around approximately 50 kgs, like for instance axitinib, till 1,000 kgs, like for instance crisitonib. And on the other point, the worldwide sales could be lower, for instance, approximately 10 million USD, or very impressive, like for instance for axitinib or crisitonib, more than 1,000. Another point is the number of API manufacturers. As you can see here, for some of these API, there are 6 worldwide commercial available manufacturers, but very few API manufacturers in Europe. And this is another list of API, very important in this class. And I would like here to point it out that, for instance, ruxolitinib is used for autoimmune disease, as well as for the treatment of breast cancer therapy, so have a different therapeutic indication. For sure, there are some risks that we need to keep into consideration, that are basically the presence of impurity in the upcycle elements. Secondly, the raw material availability and cost for large-scale production. And finally, the highly demanding chemical synthesis on large scale. In order to address and to mitigate the risk, we need for sure the involvement of a certain number of internal resources, for sure the early environment of supply chain, and then the impurities identification in the raw material and the determination of the limit in order to avoid any impact on the final API. Since at the beginning of my presentation I have summarized the sustainability goals in our company, I would like to point it out that here that basically all the action that we will put in place for NeoCycle item are strictly related to the sustainable goals, as well as our sustainability area. Particularly, we need for sure to improve the current synthetic process in terms of solvent amount, solvent cycle, reagent toxicity, and for sure we need also to eventually apply some alternative technologies, like for instance flow chemistry. So thank you very much for your attention, and if you have any question, I will be more than happy to answer.
Finally, we have Leonardo Bracchetti from Confa online. Leonardo, could you please share your screen in total screen mode, please? Leonardo, can you hear me? We don't hear you.
Can you hear me?
Yes.
Can you hear me?
Yes, yes.
I'm not allowed to present the slides. Could you show you the slides, please?
Yes. Okay, you have to share your screen, and Alicia give you the access.
Okay. I can share the slides.
try now, please.
No. Maybe just a moment. Okay.
Okay, perfect.
Okay.
And could you choose a total screen or complete screen? Yeah.
Okay, perfect.
Perfect,
Can
thank you.
slide? Okay, perfect. Hello, everyone. My name is Renato Brachetti. I'm an agronomist and project manager for Confagricoltura, and today is a pleasure to be here to discuss the techno-economic viability for Neocycle and products, particularly focusing on the commercial grade of ammonia fertilizers and their role in European agriculture. So let's say, starting by a brief description of my organization. Confagricoltura is one of the most important farmer association in Italy. Is a private association of farmers. So we represent 60% of the country territory, 20% of the agri-food turnover, 24% of the total Italian farmers people. So we have more than 140 offices all over the Italian region and represent more than 286,000 associates. And we represent and legitimate their interests at national and European level. So we are member of several agricultural organizations, as the Copacogega, that is the umbrella association of the Farmer Association, where our president is also the president. The SEJA, that is the same organization, but for the young farmers, and of the NFTPS, that is the National Food Technology Platform Food for Life. They're coordinated in different cities in Europe. Okay, here you can see some data about Confagricoltura. So we represent more than 165,000 farming businesses with hired labor, more than 500,000 hired workers, and we are involved in 35 behavior projects like Neocycle, which 16 are ongoing. So what's our role in Neocycle project? So in the Neocycle project, Confagricoltura is responsible for the analysis and comparison of different fertilizers and their ammonia content. So our main objective is to validate ammonia-based solution derived from solid-state coordination and using experimental pot trials under real economic condition. The test will be done in our experimental farm, associated experimental farm, Azienda Agricola Sperimentale Steward, that is located in Parma. So in other words, we are the bridge between laboratory innovation and field application. Okay, why Neocycle matters for agriculture? Because ammonia is the cornerstone of the modern food production. So it is the main building block for nitrogen fertilizers, which sustain nearly half of the world's crop yields. Any disruption or environmental challenge in ammonia production directly affects fertilizer costs and consequently the food production, food security, and food prices. Therefore, developing cleaner, more efficient, and more resilient ammonia production technologies is not just an industrial goal, but is also a societal need. And also, Neocycle is important for agriculture thanks to the development of catalysts and processes relevant to the ammonia. And of course, for the strategic autonomy in the ammonia production in Europe. Okay, before moving to the broader market perspective, let's a moment to look at what fertilizers are actually produced from ammonia. So ammonia is the starting point for nearly all the nitrogen-based fertilizers being converted into the more stable, transportable, and usable forms. The main fertilizers, ammonia-based, let's say, are the urea, which offer the highest nitrogen concentration and is the most widely used nitrogen fertilizer worldwide. The estimated global usage share is between 50 and 60%. Then we have the ammonium nitrate, known for its rapid nitrogen release. And then we have the ammonium sulfate, which provides both nitrogen and sulfur, and is less used than urea and ammonium nitrate, but essential for sulfur-deficient soils. Together, these compounds represent the core of the European nitrogen fertilizer market. So their availability cost, and the environmental impact depend directly on how ammonia is produced. So that's why improving efficiency and sustainability of ammonia synthesis is essential for the agri-food value chain. Let's now look at this slide. So Europe's nitrogen fertilizer market is valued at around $68 billion in 2024, with ammonia-based products that are urea, as I said, ammonium nitrate, ammonium sulfate, forming its, let's say, foundation. The production remains concentrated in Germany, Poland, France, and Netherlands, while Italy and Spain are the leader in imports. So around 34% of European nitrogen fertilizers are imported, mainly from Norway, Russia, and North Africa. And most of the European ammonia is still produced from natural gas, making the industry vulnerable to the energy and price fluctuation and geopolitical instability. For this reason, the European Union has identified green ammonia as a strategic priority, promoting the use of renewable hydrogen, carbon capture and storage, and industrial electrification to decarbonize the fertilizer sector. Okay. Let's give, let's say, an overview of the regulation about the fertilizer sector. The EU Fertilizing Products Regulation is the most important, the EU 2019-1009 that defines establish a unified European market for fertilizers, introducing stricter safety, quality, and environmental standards. So this regulation supports the transition from traditional fossil-based fertilizers to green and circular alternative that is in line with the neo-cycle vision. So according to Fertilizers Europe, that is the association of the European fertilizer producer, by the 2050, the industry could achieve 80 to 90% of the reduction in CO2 emission from ammonia production. So this can be reached through the mass adoption of renewable energy, hydrogen, strong public-private partnership, of course, the investment in infrastructure and CO2 such a transformation will not only reduce the European carbon footprint, but also will improve the strategic autonomy and stabilize the fertilizer supply. However, as we move towards a greener production, policy discussions are heating up, so especially around the use of urea-based fertilizers. Across Europe, policymakers propose restriction or bans on urea, aiming to reduce ammonia emissions and nitrogen losses. And while these objectives are environmentally sound, a full ban could serve economic consequences. And according to Assofertilizzanti, this the Italian Association of Fertilizer Company, a full prohibition of urea could lead to a 45% drop in the value of cereal production and threaten the European food security. Instead, the agricultural community advocates for balanced technological-based solutions, such as, for example, urease inhibitors, which slow down the nitrogen release and minimize emission, and precision application technique, which optimize fertilizer use, and enhanced efficiency fertilizers, so which deliver higher yields with lower environmental impact. I hope I give you a short overview of this sector, and thank you for your attention.
To finalize this panel, Dr. Peter Mogollor-Rossi have prepared some questions to the opponents. Leonardo, could you turn on your camera, please? Because probably you have some question. Thank you very much.
Thank you so much. And as we are only... Is it okay here? Okay, I will be in the middle. I love to be in the middle. So, as I am the barrier between your coffee and this project's event, so I don't want to go very much to the details. We could see a lot of wonderful science and also some industrial cases, but I want to have a more general question, and probably I will address it to Macarena, that how does this project contribute to the currently more and more important issue of critical raw materials in Europe?
Thank you. Thank you, Peter, for the question. Since I think it is very important to have in mind that critical raw materials sector depends actually in a really an absurd percentage of China. So the fact that we are able to upcycle the already wasted magnets that we would through in any other case, I think that would make us independent in that sense, and that's absolutely vital for it. So yes, the deeper we can go and the farther we can go in this sense, the more independent we can become, and that's absolutely important for this market, because as I mentioned, it's absolutely polarized towards China, and to achieve something like that, I think it's very important to have some initiatives such as NeoCycle is proposing.
Okay, my next question is about this digital passport. You mentioned that in the sector it is not a must. So how will the industry receive this digital passport thing if there is no obligation? Because based on my experience, I mean, you can develop wonderful things, but as long as it is not compulsory or regulated by law and make it really essential, industry will not spend any cent on it, and they will only start when it will be compulsory. Can you comment on that?
It will be compulsory. It will be an obligation.
When do you expect to be compulsory?
Actually, for batteries of cars, they say by 2027, it will be needed that any battery that comes into Europe should have a digital passport. They will start with batteries, but they also have other sectors already in mind, like textiles, construction, ICT goods. So it should be will be an obligation. So Europe tries to force this by regulation, while the UNDP, DPP, is driven by business interests. So in Europe, you force the industry to have DPPs, while for the supply chains globally, industries are interested. I think they see benefits, so they do it without regulation.
Okay, but what I understand from your words, we are talking about batteries 27, other raw materials probably in the 30s. So it is a long process. When do you expect to have, because you mentioned here the standard, because there are several projects, and last year we had a great event here, also organized by the same organizers, same place, a clustering event where we could see some of these projects talking about the digital passport. And as you mentioned, there are various approaches. It's not only about the data, but also the platform. So it should be standardized. When do you think that the standard will be developed and accepted?
The standards from Senelec should be published by the end of this year. The rumors say it will not be achieved a bit later, by 26, but initially by end of this year, the standards for DPP system in Europe should be available. And I think Sirpas, this flagship project, is creating a lot of energy. They have pilots, they will show it working. So I think this will be important to convince also.
Okay, thank you so much. As it is a European project, Horizon Europe project, the European Commission has various type of expectations regarding impact. Scientific impact, societal impact, business impact. So first I want to touch upon the scientific impact. And I would like to ask the researchers, how do you see how this project and your work will contribute to this expectation of the European Commission? First, I would like to ask our Polish colleagues.
Thank you very much for the question. So I think the project results can contribute significantly when we obtain the active catalyst. Because if the catalyst will be of satisfactory activity and using the recycled neodymium and iron, I think it can significantly contribute to the sustainable circle, yes. That is why for us crucial firstly to optimize the catalyst and then assess if the recycled salts can be as good as the commercial one. If yes, I can think we can make a very important and big step towards more sustainable global circle using those elements from recycled spent magnets.
Thank you. Also, I would like to ask Peter if he is still online.
Yes, I'm here, Peter. I hope you can hear me. Yes, it's a very, very good question. And we started with our scientific research years ago. Before this project, the rare earths are in our minds since 2011. It was the same situation. The exports from China were limited. And so we developed recycling processes, and we could also transform them into industrial scale. And then after this, the price decreases, drops down, so and the recycling activities were left. So we are at the same situation now. For us, from the scientific point, it is important that we can speed up the project, the technology development into larger scale, because this is one very important fact for the industrial partners to see that it's not only fundamental research, it is advanced and it is more development. Yeah? And then we have to think to the next step. If we have the technology on a not commercial industrial scale, what to do next to get this technology into the market. I think this is very, very important. It's a little bit away from the real scientific, but we have to find people or companies for investment which are willing to use this technology or to use our platform from the NEO cycle to build up such plants. And it's not only plants for the chemical processing, we also need systems for the collection of the magnets within European Union. So we did a great job at the moment with the partners from Greece and Italy, but we have to think all over Europe and not only HDD magnets from HDDs. I think this is very important.
Yeah, thank you, Peter. Especially pointing from science towards business impact, that is a very, very important component. However, this project is not an innovation action, but a research and innovation action, but still it is a very, very important factor. So I really like your approach that, yes, science is very important, but it should point to some business impacts as well. Thank you very much. So regarding societal impacts, Leonardo, can you comment on that?
So it's not simple to comment because I want to point out the agricultural side. The social side, the most important impact of this project in agriculture for the future would be, as I said, the new, let's say, fertilizer made by green ammonia in different, let's say, made in different processes. And I don't know, for sure, new products, new sustainable products should be, let's say, a great idea to the farmers for promoting also the innovation in their farms. So, it's my idea.
Yeah, thank you so much. And this again also points out that, okay, societal impact is very important, but it's also related to business impact. So let's go to the business impact, and then a major industrial player. How do you see the business impact of this project, is particularly on your business as well as probably in a broader picture, eventual sectorial impact?
Okay, yeah, thanks for your question. For sure, I have pointed out some critical points that we need to keep into consideration because in order to achieve sustainable goals, you also have to be considering a sustainable cost if you have a company. So our main effort will be to, let's say, transform the protocol that we will receive, that is the synthesis, route of synthesis that we received from University of Pavia in order to make the process sustainable, not only in terms of environment, but also in terms of cost. That means try to adjust for the selection of reagent employed in the synthetic step, as well as try to recycle solvents eventually involved in our synthesis, or apply technology, alternative technologies like for instance flow chemistry, in order to reduce reagent solvent, to reduce the waste, to make the process sustainable in terms, as I just mentioned, environment as well as economics. So for the business case, the challenge will be what I just mentioned. Another point is that in any case we will apply the use of such catalysts for in pharmaceutical ingredients as well as API that have a consistent market. So for sure there are interesting from a business perspective. I hope to have answered your question.
Yes, thank you very much. And it was also nice to hear that besides of business aspects, also other, let's say, category of impact was mentioned, which is sustainability, environmental impact, and so on and so on. So thank you. And just summarizing this impact round, it was wonderful to hear that these three categories of impact, which is expected by the European Commission, are not standalone impacts. They are interrelated. As we could hear, scientific impact interrelates with business impact, environmental or societal impact interrelates with business impact interrelates with other societal, environmental, sustainability impacts. So this also shows in a way the complexity of this project, and as we could see from the introductory session from Macarena, that it is really a very complex project and try to tackle various outcomes, various technologies, various business dimensions of this problem. And I think the panel presentations very well envisaged this complexity and interrelation between various factors. So I think it is now probably end of my session, so I will hand over the microphone.
Thank you very much. Thank you to all speakers for the insightful presentations. We will now take a short networking coffee break. We will come back in 30 minutes. And Dr. Raúl Carrillo will start with session 2. Our coffee break is in front of the stairs.
Yes.
Okay?
So 12:10, we will back here. It's okay for everyone?
Thank you.
Hello. Hello, welcome back. Now we move into session number 2, synergies with public cluster, where we will explore how NeoCycle aligns with the smart specialization partnerships and European funding instruments. Let's begin with myself, and I'm going to present the stakeholder framework. My name is Raúl Carrillo, Chief Research Officer at Ecocastulum. It's a pleasure to be here with you today, and thanks everyone, people that are present in this first NeoCycle stakeholder workshop, but also the people that are connected, because together we will make this possible. And this session is quite important for us because we are involved in a really interesting, I will say, set of tasks related to the stakeholder. We are going to start with the presentation, so let me switch the slide. Abajo. Okay, 1 second. So, on behalf of ISMC and Ecocastulum, we would like to highlight the importance of the correct stakeholder framework definition, which provides a structured approach for identifying, analyzing, engaging, and managing all the actors involved and to be involved in the project in the future phases. We are developing 2 important tasks, the task T11.3 and T11.4, that are named as clustering, networking, and stakeholder engagement. And the next one is synergies with European industrial clusters, smart specialization strategies regions, and raw materials information systems. These activities aim to strengthen collaboration, networking, and clustering with relevant European and national projects, as well as to foster synergies with regional innovation ecosystem and industrial clusters. I would like to say that the activity T11.3 focus on clustering and networking, and the main goal is to establish effective connection with synergies, with synergistic Horizon Europe and national projects for exchanging knowledge sharing and coordination. This activity begins with identification of relevant projects and initiatives that share common objectives with the NeoCycle project. The T11.4 focus on building synergies. For this activity, a development of network of sectoral enterprises is done, is under progress, and it helps us to identify a new business model for this stakeholder activity. T11.3 and T11.4, therefore, are the foundation for the long-term collaboration with the stakeholders and therefore for the own engagement. In the next slide, we present the internal methodology that consists in the following: building a partner survey and a coordinated desk review, in which we use different keywords for identifying projects that present some similarity with the NeoCycle project, like, for example, sustainable upcycling, magnets, circularity, energy risk efficiency, and etc. But also, we support our work in the next activity, which is the definition, the preparation of a stakeholder database, which is fully aligned with the LCI stakeholders mapping framework that provides us a classification by type and by sector. When I say by type, it's industrial cluster associations, policy, academia, and by sector, magnets, ADD, logistics, sustainable services, and so on. Here, for example, we can see that specific mapping that I said that provides a great view of the areas that we have to explore, but we would like to stop just a second in the involvement of 2 key stakeholders group. And one of them is really important for us because it's the public authorities. The public authorities provide regulatory frameworks, funding opportunities, and also help us to ensure compliance with environmental and industrial policies for promoting economy circular models. For ongoing projects, let's say that these contribute with the knowledge, acting as a multiplier effect, and to provide validation of neo-cycle projects innovation. Okay, if I go a bit faster, it's because we don't have too much time, okay? The next session is really interesting for the stakeholder. Regarding the slide that we see here today, for ensuring the success of the scalability, it's essential to connect our work, the work of the NoCycle project, with the existing European ecosystem. These synergies are key, like S3P, okay? European Union successful experience. An important note is that the value chain, that the value chains only work with public authorities, industries, research, and municipalities act in synchronization. Here we have the 4 axes of references that are fully aligned with the 4 speakers that we will have in a few minutes, that consolidate a great structure and strategy. When I say that, is because it provides values on the circular economy, the European Union transitions toward a circular economy focusing on sustainable management of resources, environmental sustainability, fully aligned with the environmental concerns and the mitigation measures provide for reducing the waste management, strategic raw material approaches, addressing all the existing and future efforts for the European Union in order to secure the sustainable supply of the critical raw materials, and sustainable innovation. That is the core of our project, in which we announce the research and innovation capacities to tackle societal challenges, in particular in sustainability. Here we have a quick presentation about the session, the speakers that we will have. It's quite interesting to listen carefully what we are going to present, because it's the basis of our activity. The first one, Andalusia mining in use, S3P. The name is Interregional Europe. The overview of the sustainable mining strategy and how regional policy permitting modernization and industrial symbiosis can host no-cycle pilots. The opportunities for the no-cycle basically is that provides the opportunity of the raw material recovery from tailing and industrial with end-to-end traceability. Another one is the circular batteries for Lombard Intelligent Factory Association. Here, Fields plays a role as a cluster orchestrator, focused on circular battery recycling. And the main opportunity for NeoCycle is the standardization, the traceability, and the cross-regional supply chains. Let's also explore another S3P opportunity, okay, which is the agri-food traceability, S3P agri-food. The opportunity here is to connect the agri-food logistic and retail nodes to pilots on material passport and circularity reporting, replicate through the S3P in regional network. Here, the waste, electronic and equipment, collection and critical raw material, municipal waste, Europe. Basically, they will talk about the policy and practice, the collection model, citizen engagement, the feedback from local level linking directly to the no-cycle critical raw material, recovery ambitions. And finally, in this slide, we want to give visibility to 4 projects as a part of the pitching elevator session that will serve for the current pathway from policy and regional framing. The first one, Raw for Rest, is focused on the maps of regional needs, the governance and the raw material experience, from the R&D and validation, Crusade and the permanent, and finally, for exploring the KPI indicators, the capabilities, the expo skills that builds the workforce and the institutional capability. Well, I would like to finish the presentation telling you that these 2 activities have a clear aim, which is a clear goal, which is to establish effective connection, as I said, with relevant projects, cover, or I will say, under the umbrella of the European Union, because we want to provide the maximum visibility of the no-cycle project advancement and also be connected with the future or with the next steps in terms of R&D, but also future uses, as well as to convince the public opinion that at the end of the day, in some cases could be a bit challenging, that we're doing something innovative, but something that will create a conscience of sustainability and also circular economy. And with this, I finish my presentation. As I said, I don't want to spend too much time because now we have synergy with public clusters that are really interesting, and I would like to give the floor to some of them. The first one is named the Smart Specialization Partnership Andalusia Mining Use Case, presented by Manuel Vázquez Mora from the Directorate General of Mines of the Regional Government of Andalusia. So the floor is yours. Oh, sorry. Oh. Espera. Okay. So. Para abajo y este. Vale.
Hi, good afternoon, everybody. Thank you for inviting us to this interesting meeting, and welcome to Andalusia, our region that have a very long tradition about mining. My name is Manuel Vázquez. I'm mining engineer. I'm working as a senior advisor in the General Directorate of Mines in the regional government of Andalusia. In my presentation is focused on the S3P mining regions. It's a platform coming from the Smart Specialization umbrella from the European Commission. We are, as a region, part of this platform from the beginning of this platform in 2019. Sorry. No, esta es la que le doy, sí. Well, this platform, as I said before, is coming from the umbrella of the Smart Specialization platforms from the European Commission. Is formed by these regions, is leading by Lapland region in Finland, and the partner regions are North Karelia, Kainuu, North Ostrobotnia, and Central Ostrobotnia, also in Finland, Bergslagen, Västerbotten, and Norrbotten in Sweden, Castilla y León, Andalusia, and Asturias here in Spain, Alentejo and Central Portugal in Portugal, and Central Greece, and Nouvelle-Aquitaine in France. Also, this platform have also associated partners. Some of the regions are associated partners. This is one of the main tasks we have now in the future, is to increase this number of associated partners. We can sorry. You can see here in this slide the main regions and the main associated partners. In Lapland, many of them are coming from the university, and also startups and regional development centers like the Gibolis in Kemi in Finland. Here in Spain, we can name also the University of Oviedo and the Iberian Sustainable Cluster. And finally, in France, the Pôle Avenir is also one of the main associated partners. What is the mission of this partnership? The mission of this partnership is focused on the CRMI objectives. Is the critical raw material objectives are the main task of this partnership. It promotes the regional economic growth and a sustainable and secure supply of raw materials, and by strengthening the regional small and medium enterprise, trying to involve them in the industrial value chains as auxiliary companies from the main mining companies. Also, this partnership will incorporate the mining region innovation ecosystem, as the colleague have mentioned, to generate new development and investment using available financial instruments. One of the instruments are these European funds to help us to develop the innovation we are searching now. The partnerships units the capacity, expertise, and skill of European mining region innovation ecosystem, and this is one of our main goals. We are trying to define to increase the companies and the entities that should be part of the regional ecosystem, the regional innovation ecosystem. All the potential partners or associated partners are invited to take part of this partnership. The area we are focused are supporting development of sustainable business model, and of course engaging regional small and medium enterprise to create a local economic value. The main or final goal is to improve the citizen well-being and the local acceptance of mining in the region. And yes, optimize the use of available financial resources and to take the regional planning should take into account the industrial needs that is not usual to have a target for this by the moment. The main activities of the partnership are focused in 4 groups: economics, environment, social and policy EU. The economics is focused on the competitiveness and the small and medium enterprise, and also in the regional and interregional hubs. The environment activity or working group is focused on all regarding the mining waste, also circularity, the rehabilitation of the abandoned mine sites also. The social is very important for us, is to build all we need to achieve a better social acceptance for the society in general and the local communities in particular. Finally, the policy use is a working group focused on amplifying the regional voices in implementing the critical raw material act in every region through the policy instruments. In that case, they have as we have in Andalusia. Some related project from this partnership, I would like to to select this 6 DG Eco Quarry is focused on circular economy, but in the environment of aggregates production. The SIMING CRM is an Horizon Europe project focused on critical raw material coming from all stockpiles of in abandoned mines or even in active mines, but with a very large or very long activities. I4Green is an I3 founded project focused on recovery of rare earth, iron, copper, zinc, and lead from with two pilots, one in Extremadura and another one here in Andalusia. This project has finished last year, and yes, the result was very interesting also. The RISE project is a project focused on accelerating innovation in less developed regions, not only for mining or for minerals, but with an important focus on this area. IRM Hub is a Meta Hub project that is focused on circular economy, all the tasks related to the critical raw material for batteries, for microchips, and renewable energy. And finally, MRIE project that has been mentioned by the colleague is this is a Interreg Europe project that has started this year in May. Here we are. Well, this is a kind of support coordination action that try to analyze and share the way the different five different regions in Europe are implementing the Critical Raw Material Act through a process named I would say learning journey. Sorry, learning journey is the process this project has designed to run the way to reach the objectives. And this is a 4 years project. Yes, here in Andalusia, we are involved also with the ISMC, CTA, some of the main stakeholders like the regional mining association focus on metallic minerals, industrial minerals, aggregates, and natural stone also. Well, this is the scope where this project, this Neocycle project, can interact, can have the place to new developments and new and the share of new experience. Well, this is the main comment I have to say about our partnership here in Andalusia. I have more information about the MRIE project, but as the colleague said before, we prefer to know all another partnership information. Okay. So that's all from my side. Okay.
Thank you very much, Manuel. It's quite interesting to see the synergies that we discover, basically that pillar that goes in the direction of the sustainable mining. Okay, the next presentation is named Circular Batteries Recycling from Eda IPEC from the Lombardy Intelligent Factory Association. It's online. Let's see if everything goes well.
Good morning, everyone.
Okay.
I hope you can hear me. Yeah.
So
okay.
the floor is yours, and you can start when you want.
You 1 second. Let me share my screen.
Yeah, sure, no problem.
So should be like this. I hope you can see it. I guess I take this as a yes. So thank you all for the invitation. Just a quick introduction. I'm Eda Ipek. I'm a project manager for AFIL. AFIL is one of the 9 regional clusters working in Lombardy region. So as one of these clusters, we represent the advanced and sustainable manufacturing. As AFIL, our mission is to set up a stable community. So we try to connect companies, universities, research institutions, and associations to promote networking activities, of course, that will then evolve in a research and innovation project and initiatives. We are also the reference actor for the Lombardy region, so we represent the Lombardy region in general when we talk with our stakeholders, and we are the reference point when it comes also to this smart specialization strategy, as this cooperation that we have with the companies allows us to get the insights from the companies. And we are also the ones that try to position the Lombardy on all the international and interregional networks as we represent the Lombardy region. We are an association that has 140 members. As you can see here, 80% of these members are industrial, so SMEs and large enterprises. And then we have 10% that are research centers and universities, and 10% association, mostly business support organization. As you can see, we are directly linked to Region Lombardia as we were wanted and then recognized by Region Lombardia. And we're also part of different European initiative. So the first one that you can see here is the national cluster on advanced manufacturing called the Fabbrica Intelligente. And then we're also part of the European Cluster Collaboration Platform, the Smart Specialization Platform, the Vanguard Initiative for Motors for Europe, and the World Economic Forum. But how does exactly AFIL work? So in order for us to make everything possible, we created inside the AFIL these working groups called strategic communities. So, of course, we don't force anyone to participate in the strategic communities, but we kindly invite the stakeholders to participate, as this is a moment for them to do networking and also to have a moment to talk to stakeholders dealing with the same challenges. So it is very important for us to facilitate the conversation between different kinds of stakeholders to find a solution to the problems that most of the stakeholders have to deal with. So we have different kinds of strategic communities, but for today, I will just focus on the DNR manufacturing for circular economy. So the objective of this working group is the development and implementation of innovative materials, products, technologies, and processes for reuse, remanufacturing, and recycling. And the topics of interest are the reuse and recovery of composite materials, the reuse, remanufacturing, and recycling of batteries specifically, and the circular economy solution for the textile and the steel sector. Just focusing 1 second on the batteries. From this working group, we have 2 projects that were born. So one is the Cari service, that it is a project that already ended in 2021. And this project aimed at demonstrating the innovative reuse, remanufacturing, and recycling technologies for the electrical vehicles. And then we have BATMAS, which is a project that started in September 2023, and it is going to end in February 2027. And it has a budget of almost 14 million euros. I will talk more deeply about it later. On regional level, as a cluster, we also try to help Regional Lombardia when it comes to their policies. So what we did in 2020 was a roadmap on circular economy to identify the regional priorities and challenges. This was done together with our working group. And this was followed by another roadmap on artificial intelligence. Again, all of these are always done side by side with our stakeholders. So nothing comes directly from us, but from the ecosystem that we work within. This roadmap then was adopted by Lombardy region when it comes to the policies that they're going to implement. And it was also the input to launch the regional circular economy hub, which was focused on circular economy solution for the mobility sector. So here you can see the universities and the research center that collaborated with us for the Circular Economy Hub. So we have the Polytechnic of Milano, we have the University of Pavia, University of Milano Bicocca, University of Milan, and CNR Stiva. Concerning the European level, we are part of the Vanguard Initiative and of the Smart Specialization Platform. So we are coordinator of the ISMC pilot in the Vanguard Initiative, so of the efficient and sustainable manufacturing, which is coordinated by Marcello Colledani, who is also the coordinator of BATMAS. And within this pilot, two projects were born, and later also BATMAS, which were Cari Service and DigiPrime. And we're also part of the smart specialization platform. And more specifically, we focus on the industrial modernization part. So we are part of the partnership of the efficient and sustainable manufacturing, 3D printing, AI and HMI, advanced materials for batteries, and European wireless ICT. For the purpose of this presentation, of course, we're going to focus on the advanced materials for batteries, which focuses on the sustainable raw material extraction and processing, the improved batteries for mobility application, improved batteries for stationary storage application, recycling and remanufacturing of existing lithium-ion batteries, and of course, the development of networking for research and testing centers. So, coming now to the project that I mentioned before, which is BATMAS. BATMAS is a project of 4 years with 15 partners and 11 regions. The BATMAS is co-funded under the Interregional Innovation Investment Program that was also mentioned before by Manuel before. And what differentiates this project is that when the project ends, it doesn't really end, because the idea is to scale up, commercialize, and implement the technologies that were developed throughout the project. So the idea of this project is to establish an ecosystem for the circular economy in the battery sector, and this will be done by this circular battery valley that will be created. That will focus on the entire life cycle of the battery, so from production and usage to second life and recycling. BATMAS is created around these 4 demonstrators that we'll see a little bit later, and it depends on the technologies that these 4 demonstrators are gonna develop and then implement. So, but what was the reason that made us create BATMAS? As you know, there is an increased demand for electric vehicles. This means that the battery production is also going to increase, and then there is going to be a problem with the used and exhausted batteries. There is a huge dependency of Europe on third countries when it comes to critical raw materials. So it is really important for us to make sure that Europe can be independent when it comes to critical raw materials. And also, of course, the whole objective of the sustainability and circularity of batteries. Here you can see the idea behind BATMAS. So a circular battery valley will be established around these 4 demonstrators that I mentioned before. So we have 4 demonstrators that will close the loop, so the loop that goes from material waste to production loop. And it will rely on the collaboration of the triple helix, but also on the engagement of the investment community, because we don't want this project to end, but this project is going to go on. of course, until we can, and until we will get investments on the technologies. So going a little bit deeper on the demonstrators, the first demonstrator is the batteries collection and dismantling. So here we will have the development of an EPR-based digital platform. This demonstrator is led by ERP Italia Servizi, Politecnico di Milano, and NdFeB, which is a Spanish company. And they will work on the EPR-based digital platform on a modular safety packaging for the batteries for when they are in end of life, and for the disassembly and deactivation systems. Then we will have the demonstrator 2, which focuses on the second life of these batteries. And this one is led by NdFeB and Green Vision. Green Vision is also an SME from France. So the idea here is that NdFeB will work on the development of a power wall. So it is a modular storage system designed for stationary use in homes and the industries. And then Green Vision, on the other hand, will work on the design and development of a new direct reuse of Second Life stationary system for as well domestic usage in this case. Then we will have the demonstrator 3, which is led by Orano. And here we will focus on the recovery of the critical raw materials from end-of-life EV batteries, and also from waste scraps from gigafactories. This is made possible by the pre-treatment and hydrometallurgical pilot that it is already at a high level, so it is around the tierras 7. And then to finish the demos, we will have the demonstrator 4, which is led by Vercor and Orano, which are both Vercor is a gigafactory in France, and it will focus on Orano's production of pre-cam and cam using material that is recovered by in demonstrator 3. These then will be supplied to Vercor for the fabrication of lithium-ion pouch cells. I know this part was very technical, so I'm sorry if I did some mistakes, but this is all from Batmar. So if there is any question, I hope I will still be here later. So thank you for the attention.
Thank you very much for the presentation. The next one, it's another case, the Smart Specialization Partnership, Traceability and Big Data in the Agri-Food Value Chain, presented by Milagros Arguelles from TRAXA, Regional Ministry of Agriculture, Fishing and Environment of Andalusia. So the floor is yours. Para pasar las imágenes aquí, el de abajo. Sí, el de abajo.
Gracias. Well, first of all, good morning or good afternoon. I would like to apologize, Marc Cátedra, who was supposed to be here but has another meeting in Malaga, so I will make the presentation on behalf of her. And thank you very much for inviting us to take part in this event, because as we have been discussing, these sort of events are very important to learn from each other, to exchange experiences and knowledge, so that we no longer stay in our silos, and we share from successful stories and from failures, and how we have overcome difficulties also. My name is Milagros Arguelles. I am Technical Project Officer at Traxatec, which is a public company, and we provide support services to the Regional Ministry of Agriculture in the coordination of the S3 thematic partnership on traceability and big data. This partnership was set up in 2017. I think it was one of the first ones. It was part of the agri-food platform, and a few years later joined the industrial modernization platform. So one partnership, but we are part of two platforms. We are now 32 regions, public administrations, RTOs, universities, and other sort of institutions from 14 countries. And these regions involve more than 2,100 stakeholders. I will explain it later. And the regional ministry is the regional ministry of agriculture is the coordinator of the partnership. So we work at interregional level, but also at regional level. So the regions and public administrations, we mobilize regional actors, and they also mobilize and connect regional actors from the quadruple helix, other public administrations or institutions, RTOs and research centers, universities, etc., business sectors and civil society. So that we have like 2,100 stakeholders involved in the partnership. Some of these regional nodes have evolved into what are called the European Digital Innovation Hubs, such as in Andalusia, where we have the Andalusia Agrotech European Digital Innovation Hub. So we started as a public administration with a partnership, and now we have a D, which is a very important tool to provide a certain portfolio of services to companies. These are the priorities or focuses of the regional, of the partnership: the life cycles of the value chain, the monitoring of the value chain, consumers' feedback, and of course, technologies, digital technologies, open data, interoperability, and cybersecurity. I'm not going into much detail about the projects because we have been running like 77 projects, 55 are ongoing from different European programs, mainly Horizon Europe and Interreg. We have 9, as I said, with the Andalusian one, 9 regional nodes have become European Digital Innovation Hubs. Then we have also projects funded with ERDF regional operational programs, one Erasmus Plus, etc. You have all or most of the information about these projects in the partnership website. We are involved in platforms or alliances like the S3 Community of Practice, which have provided the partnership with 3 main services from experts of the EU Commission for funding, re-scoping of the partnership, and demonstration, which was focused basically on how to approach the results of our projects and activities into the market with higher TRL levels. Another alliance is with the EIT Food, and one very recent is the Agriculture of Data Partnership that has been launched like 2 weeks ago with a life expectancy of 7 years and 300 million euro budget. Don't know much yet about this partnership because it has just launched, but we have very high expectations about the results and the exchange of information and progress with this partnership. The partnership is organized around 3 working groups. Progress is at a very different pace. Roadmap and circular economy are much more advanced in terms of they have already completed the mapping, so we know exactly more or less what our partners' needs are and what we want to do. And we are now in the phase of looking for mainly Horizon Europe and E3 calls for the next year. So we are organizing potential partnerships and groups of members that are interested in submitting proposals to the next year calls. In addition to the more technical activities like projects, etc., one big activity of our members and we as coordinators is for communication. I think we have all mentioned somehow how important it is to raise awareness, to make people aware and companies about the importance of circularity and resource efficiency, sustainability, and these issues. So we have a partnership website where you can find information about the projects, the stakeholders, and other activities like the newsletter. We issue every 2 months a newsletter where we inform about activities developed by the partners, news from the European Commission, coming calls, or open calls, and also key documents and multimedia support. So you can access the website and the newsletter. And also we are very active on social media, X, LinkedIn, YouTube. If you want to stay tuned about our activities, you can follow us. And just a few figures of our partnership. Since 2016, more than 8 years experience in the development of digital solutions for the agri-food sector, 35 best practices that were a result of an Interreg project, Interreg Euro project called Regions for Food. You can find them in the partnership website. Interregional study visit with the aim to learn from each other by in situ, which is the best way to really know what others are doing and show what you have to offer. And also the recognition from the European Commission of 2 best practices, one from Andalusia, which is how we have managed to mobilize regional resources from our operational ERDF fund to coordinate the partnership. One of the main challenges of these S3P partnerships is funding. We depend on public funding and we receive funding from projects, but coordination is not always an easy issue to solve. So we have been able to get some funds from our operational program. And then another best practice is the fact that we have involved partners not only from the European Union, but also from outside, like Turkey partners that we have. And that's it. If you want to know more, you can follow us, X, LinkedIn, and YouTube, and also you have our email address and the website. Thank you very much for your attention.
Thank you, Milagros. Okay, the next presentation is named Waste Electrical and Electronic Equipment from Waste Electrical and Electronic Equipment Collection for the Recovery of Critical Raw Materials from Estefania Jimenez Puerta, Municipal Waste Europe, and she's connected online. So please, can you confirm
yes.
that you can listen us? Okay.
Yes.
clearly. And you, can you hear me?
Yeah, we can listen to you.
Great.
Okay, so
I will share the presentation.
Yours.
Thank you. Okay. Can you see the presentation?
Yes.
Yes? Okay, fine. So I'm Stephanie, I'm policy officer at Municipal Waste Europe. Let me quickly to introduce you to my association. Municipal Waste Europe is a non-profit European umbrella association representing public responsibility for municipal waste management. So our focus is on solid municipal waste. We were founded in 2009 and we are based in Brussels. Our members are mainly national associations or regional associations of public waste management companies or the local public authorities, municipalities. So my objective today is to introduce you very quickly, because we don't have much time, to the role of municipalities on WE collection. When I say WE, I mean waste from electronic and electrical equipment. I always want to, I like highlighting the waste hierarchy because this is in our daily work. We promote the waste hierarchy. It's legally binding in the Waste Framework Directive, but unfortunately not fully implemented today. So just to keep in mind that we need still to do a lot on prevention, reuse, preparation for reuse. So yeah, I wanted to highlight that. Let me also to highlight, I think another speaker mentioned this earlier, why is we so important today? I would say that we has a political momentum, at least in Brussels, because the energy and digital transition that the European Commission is trying to push for, and this geopolitical, we has a geopolitical interest because of, this was mentioned before, the critical raw materials embedded in this kind of waste. We are dependent on the imports of e-products and also critical materials from non-EU countries. So this is a matter of EU self-sufficiency. Having said that, we also need to keep in mind that the generation of this kind of waste is growing. And unfortunately, half of it is lost in incinerators, landfills, or even exported outside of Europe, and very often through criminal activities, they are simply lost. We don't know the destinations of much of this waste. I also would like to invite you to keep an eye on these three pieces of legislation, the Circular Economy Act, the revision of the WE Directive, and the EU budget for the next years, because these three pieces of legislation will actually determine in future how we will be managed better, hopefully. Regarding the role of my members, the municipalities, let me to clarify, local public authorities hold the legal responsibility to ensure that waste management is a service provided to all residents, regardless their location in the territory of a member state. And that, of course, includes this kind of waste, from private households. This is the kind of waste you can you have at home. You can imagine everything devices you can find at home. It's under municipal responsibility. The municipalities can do this either through public, through their own companies, or through tender. So other private companies can do this service on their behalf of municipalities. And of course, you know better than me that this waste contains many of them contains permanent magnets and valuable critical raw materials. So the collection and efficient collection is very important. Let me quickly also to introduce you to how the municipalities collect and
this is the main collection methodology for we, is the civic amenity sites. In some countries, you call it recycling parks. In Sweden, for example, in Belgium, in Spain, we call it punto limpio, punto verde. But in general, we use this terminology, civic amenity site. These sites are normally located at the in the outskirts of the towns and cities, and you usually go with your car and dispose of your waste, not only we, with the help of the operators working on the site. You can see on the left side, how some kind of we is collected. You can imagine that the storage places needs to be waterproof, fireproof, to keep the recyclability of these materials. And yeah, in short, this is the main collection methodology. But we have other collection methodologies that are closer to the citizens, even more convenient, like door-to-door collection. I will not explain in detail because I don't have the time. Also, mobile collection. Mobile collection is very interesting because you can, it's a way to make the collection point closer to the citizens, and you can dispose of your small and medium-sized from home. And there are other like urban street billboards for batteries, a small we, or even street containers, other also innovative collection methodologies at stores, at schools. So these are all examples put forward by public companies or municipalities. Finally, to finish my presentation, I would like to highlight what are the problems or pitfalls we find in the daily work of public companies and municipalities in the collection of we. One is the cost. You know that we is under extended producer responsibility, and according to the Waste Framework Directive, at least 80% of the collection cost should be covered by the producer. However, there is an inconsistency in the legislation, in the WE directive, because only the cost of the collection at civic amenity sites is covered, generally speaking. So other very convenient collection methodologies are overlooked. So those municipalities who don't have the means, the financial means to put forward these very efficient collection methodologies, they cannot do it because they don't have the financial support of the extended producer responsibility. Then another issue is a fire hazard. This is really, really an increasing problem because of the lithium batteries and other batteries embedded in products, not only in electrical and electronic products, but also other kind of products like smart clothing and things like that. So there are, this is putting at risk the operators and also the infrastructure. And this is also, let's say, preventing insurance companies to insure recycling facilities, but also collection facilities because of this fire hazard. This is really a problem we need to keep an eye on. And finally, the criminal activity. Collection points are attractive targets for burglars seeking for these valuable scrap and raw materials embedded in we. So this also entails costly deterrence measures that municipalities also need to face at the expense of the taxpayer. And then the informal collection. I mentioned before that a lot of much we is simply lost because of the criminal activity. And that's it. I hope I was clear. And if you have questions, don't hesitate to contact in LinkedIn or by email. Thank you.
Fania, thank you very much for the presentation. And now we go with the last one, presented by Olgu Gassin from Foro Tosam. for the strategic framework for product sustainability and circular economy presentation. So please confirm that you can listen us and try to share your screen.
Hello, I'm listening.
Can you hear me?
Yeah, I can hear you.
Okay. Now we
Just
see
a
you.
second. Perfect.
Please share your screen. Not now.
Okay, can you see it now?
1 second. Let's see. Not yet. Now, yes. 1 second. We have an issue with the screen. Full screen, please. Okay. Oof. It's a problem for here or for us?
No, you
Okay.
still cannot see,
I
right?
think we can move forward.
Oh, okay, okay, perfect. Hi everyone, I'm Olgu Çalıncoşar from Ford Otosan. I studied material science and nanoengineering, and now I'm working for 1.5 years for Ford Otosan's Research and Development Center. Today, I won't be presenting you about a specific project, but instead I will introduce our company's approach to sustainability and circularity, and I'll try to tell the approach of an automotive manufacturer's understanding of circularity and their needs. So let me introduce our company briefly. Ford Otosan is a joint venture with Ford Motor Company and Koç Group in Turkey, and it works with Ford of Europe. It has more than half of the production capacity of Ford of Europe, and it is the export champion of Turkey for 8 consecutive years. We have more than 25,000 employees. And our sustainability targets include both environmental, economical, and sociological sides of sustainability. So we aim to reduce our carbon emission by making our facilities carbon neutral by 2030. And also our goals affect our choices of partners and suppliers. So we need our suppliers to be approved and be carbon neutral as well. And other than that, the company prioritizes the diversity and inclusion for the sociological part of it. And I personally work in the circular economy and product circularity in my team. My team, called Product Sustainability, works in 3 main pillars. So the first is sustainable material application. Its main focus is to reduce the weight while maintaining the component strength, and to increase recycled content while keeping the quality high. So the main materials which are focused on are plastics, steel, and aluminum, because they just include the most weight and volume in a vehicle, and they are strategically critical because, for example, steel is a carbon-heavy product by its production, and now we try to include the projects about green steel production, which can reduce the carbon emission by its production mainly. And I personally work in circularity of products. Other than lots of European projects under this topic, and also under the topic of sustainable material applications, I want to highlight an issue, which is electric vehicle batteries. We expect to face a huge issue about waste batteries starting from 2028 and 2030 maybe. And we may not be able to build enough plants, recycle plants, to deal with all those tons of batteries. So that we are in a search of different solutions. And our first project is try to utilize waste batteries in energy storage system. And this energy storage system also provides an arbitrage to create an economical benefit for its users. Also deals with some of the waste batteries which are below 80% state of health, so that they cannot be used in vehicles anymore, but they can be still used in another application such as an energy storage system. And last but not least, the life cycle assessment pillar of our group works both on projects such as Horizon projects and our own vehicle projects. So they assess all the vehicles and vehicles components, each component for their carbon dioxide emission and their environmental impact from its cradle to grave or even cradle to cradle. And this is also highly critical study area, both because of the environmental goals and to be a part of regulations from Europe and local regulations. Here's a list of our Horizon projects which we contributed. Actually, you will listen a Permanent and Crusade from our partners later on this event, so I won't be giving any spoilers now. But what I can say is we prioritize repairing, reusing, and recycling critical components of vehicles as an OEM, because it gives, on that order, they give the most economical and environmental benefit, actually. So each project includes some form of recycling or recovery, let's say. And the components which are highly critical means that they have high economical impact or high environmental impact, such as EV batteries, autocatalysts, and EV motors. For example, autocatalysts have lots of critical raw materials, which are highly expensive and also rare. We can include e-motors for their permanent magnets and for their rare earth element content. And also they have a high environmental impact because they have high carbon footprint when we think about autocatalysts, for example. And also you see tons of regulations here, and mostly ELV 2031. And about our ongoing activities and future scope, we recently started work on rare earth elements and green steel. So we try to reduce the impact of critical raw materials. We also try to increase our content of recycled plastics. I am open for any questions, and here is our contact. If you want to reach us for any questions or any potential partnership, we appreciate that. Thank you.
Thank you very much. Following our agenda, we're supposed to have the panel for question and answers, but since we are late with the entire program, we prefer to cancel this panel, and we will formalize the list of questions in a kind of formal email, and that will be included as a part of our deliverable. So the session number 2 ends now. We will go now for a lunch. We will come back at 2:30, okay? Please try to be punctual because the next session is very interesting and we want to pay attention as much as we can because it's an essential part of the stakeholder exercise that we are discussing here today. So enjoy and see you in a few minutes. Bye.
So welcome back, everyone. I hope you enjoyed your lunch and had the chance to connect informally between each others. I have to apologize because the small delay that we happened actually because the rain outside and then inside, as you can see, but everything is solved because the staff of the hotel is fantastic. So we move forward into the stakeholders project session. I would like to introduce Maika Diaz Aguilar from Funditec, that she will introduce the first project, that is Row for Res.
Déjala ahí si quieres. Good afternoon, everyone. Thank you for your introductions. It is a pleasure to be here today in this interesting stakeholder meeting. Before to introduce the Row for Res project, I would like to do a short presentation about my organization. My organization is the Foundation Scientific and Technological Park of Extremadura. It's governed by a public law and is based on core in Extremadura regions. Our main goals is to strengthen the region's socio-economic use of the science and technology and research result. We have two important parks, one of them in Cáceres and another in Badajoz. In total, 5 buildings in the region, around the Extremadura regions. More than 100 companies and 1,700 workers are hosted in our building. And 52 projects ongoing in the last 3 years. 2/3 have an international scope. And one of them is the Row for Res project. I would like to explain the European context for Row for Res project. The Row for Res project is an Interreg Europe. The Interreg Europe is a program funded by European Union. Its main goals is to help regional and local government design and offer better policies, public policies. The tool is the policy instrument, like strategies, action plan, law, used by authorities to improve a region situation. The program promotes cohesion by the sharing experience between regions, transferring good practice, and working together on joints, on action joints. The idea is to raise more integrating and sustainable public policy results. Here you can be the main principle of the Row for Res project because the project aims to make the raw material sector more resilient by promoting better policy solutions. You can see in this slide the more principle or solution that the partnership are working at the moment. First is work to strengthen the policy's strategy for sustainable and responsible extraction, processing, and second life use of raw material in the regions involved. The second is helps create joint mechanisms for open discussion and cooperation among the industrial value chain, local communities, and civil society organizations. And the last is the project support a policies environment that motivates green finances and eco-innovation, specifically for recycling and reuse. This is the main principle or solutions that all partners are working together, but the project have two important objectives. These important objectives are four. The first of one is evaluate and forecast vulnerability in raw material that affect regional economies and propose mitigation measures to make value chain more resilient. Second is work to streamline and promote sustainable, environmentally responsible mining policies, principles and practices. And the third is support open dialogue and consensus building between local communities, civil society, businesses, and other stakeholders, which help to solve conflict. And the last of them is promote circular relationships in metal and industrial value chain, aim to maximize resources efficiency, reduce waste, and improve the potential critical raw material in the regions. Of course, this is done through international cooperation. For this reason, you can see in this slide, the Road for Red project brings together 8 organizations from 6 European countries. These organizations include regional authorities, municipalities, development agencies, and advisory partners. They combine knowledge from Greece, Denmark, Slovenia, Romania, France, Spain, by working together. This multinational cooperation allows the partner to compare situation, share solution, and apply what works best in the different regions. So now that we know who is involved in the project, let me place the project in time. Road for Red project started on the 1st of March 2023. At the moment, we are at the end of the core phase, and finally the project will finish in May 2027. The project contributes to the policy objective Smarter Europe, specifically focusing on improving SMEs' competitiveness. The project budget is about €1,580,000 euros. Now, we'll move to where the impact happens in policy instruments. The Road for Red, he worked with several policy instruments from different European regions. These include regional operation programs, development program, climate plan, circular economic action plan. This structure ensure that the policy changes are connected to the real institution so that the result can be applied in practice each regions. Fundecid, in our case, is the smart specialization strategy, RIS3 technical office supporting our regional government. For this reason, we chose the RIS3 Extremadura 2027
as our policy instrument that we want to improve and impact. With improvement, we have asked ourselves, do we expect a sad result with this work? Through raw forests, we expect several policies improvement in the partner regions. First, policies should reorient the mining and processing sector toward greener and more responsible business practices. Second, they should improve the performance of the territories in recycling raw material and promote new investment in European regions. Third, the policies aims to improve living standard and increase the resilience and value chain against social challenges. They also address key topics like digital transformation, emission reduction, eco-design, and recycling. In addition, they will help upscale institutional capacity to create incentive to the reuse of coal waste. And finally, they should facilitate the expansion of territorial innovation ecosystem. To conclude, the project foresting chains in the different groups. The one group is funding and incentives for enterprise, for example, sustainable and responsible technology and practice, and circular economy scheme. The second group is the fostering and stronger integration with European Union value chain, for example, risk mitigation measure, business support for SMEs, and stimulate funds for setting up critical raw material recycling ecosystem. And the last, it is very important too, because it's the social approval. It's very important to integrate the civil society and all stakeholders for the consultation processes, to motivate the local community and relevant stakeholders in the project planning. And finally, this is our website. It's typical website belonging to the Interreg Europe project. You can find all information about the raw forest projects. There is a library. On the library, there are important report and document and policy brief that all partners are working together. Good practices about the critical raw material and policies. And if you want, you can follow us and you subscribe our newsletter. And of course, the project, we have a social media in Facebook, YouTube, and LinkedIn. Thank you for your attention, and it's okay.
Thank you very much, Maika. Quite important, the regional policies and the resilience that you were talking about in the raw materials value chain, that they go through the smart specialization and the regional collaboration in order to reinforce the Europe's strategic autonomy. Let's go right now to the Crusade Horizon Europe project. This will be with Vasiliki Alexiou from Monolithos Innovation, that is online. Can you hear us, Vasiliki?
Yes, I can hear you.
Fantastic. Could you please share your screen in full screen mode? I will change. Ahora cambio ahí. Okay.
Can you see the slide?
Yes, now we can see it. Could you please go to full screen mode? Okay, no, yeah.
Is it okay?
Yes, that's fantastic. Thank you. The floor is yours.
Thank you. Thank you. Good afternoon, everyone, and thank you for the invitation and the opportunity to contribute to this first no-cycle stakeholder workshop. My name is Vasiliki Alexeou, head of sustainability department and general manager at MNLT Innovations. Today I will share sustainability insights based on life cycle assessment from our experience in European projects on circular permanent magnets, how the environmental footprint of permanent magnets can be reduced through two complementary pathways, recycling of rare earth magnets and substitution with rare earth free alternatives. Of course, the purpose of this presentation and this session today in overall is to connect and identify opportunities for collaboration, knowledge exchange and clustering that will enrich the European resilience in critical raw materials. As we all know and discussed today, over the last few years, Europe has recognized permanent magnets as one of the most strategic components of the energy transition, directly linked to e-mobility, wind energy, robotics, industrial motors, and also defense applications. However, at the same time, Europe remains highly dependent on the imported rare earth elements, especially neodymium and dysprosium, mainly from China. So in this content, recycling and the substitution are now seen as complementary strategies in order to reduce raw material dependency and improve the supply chain resilience. Life cycle assessment is an essential tool to compare circular solutions and ensure that we can actually reduce the environmental impact. And of course, at the same time, we have also heard the presentation about all the European legislations and policy frameworks that now requires sustainability evidence, especially under the Critical Raw Materials Act, which include targets for recyclability, recovery targets, and environmental reporting. Let me also, before we begin, introduce the company I represent. MNLT Innovations is a small, medium enterprise based in Greece, established in 2018. We specialize in engineering consultancy, particularly in business planning and sustainability assessments. Our focus is on creating tailored strategies to commercialize innovative ideas, conduct sustainability life cycle assessments in order to ensure environmental and economic viability, and establish long-term collaborations across Europe. And also, MNLT provides expert project proposal writing services in order to guide our partners in securing the funding necessary to drive their innovation forward. With over 7 years of experience, MNLT Innovations has contributed to more than 20 European research projects. Our work covers several sectors that promote sustainability and innovation, such as climate change, mining, critical raw materials, and applications in artificial intelligence. So this slide gives a quick overview of our portfolio of products. In most of them, we lead sustainability and exploitation activities, making sure that its innovation is not only technically strong, but also environmentally and economically sustainable. In Europe, as we have discussed, permanent magnets are essential for all strategic sectors such as electric mobility, wind energy, and industrial motors. However, Europe is highly dependent on imports of rare earths from China. And here you can see some statistics. Today, 48% of rare earths comes from China, 28% from Russia, and Europe recycles less than 1% of permanent magnets. The Critical Raw Materials Act now requires at least 25% recycling of critical raw materials by 2030, highlighting the need to keep materials in Europe. So the key message is that now circularity is a strategic necessity in order to reduce raw materials dependency and lower the environmental impact. And that's why projects like the NeoCycle and all the projects that we have and we will discuss today is really important towards this green transition that Europe wants to achieve. So to address this strategic dependency on rare earths, Europe is now following two main pathways for permanent magnets. The first pathway is substitution, regarding in terms of developing rare earth-free or low rare earth magnet alternatives. This approach is being advanced in the passenger project, where new magnet types like manganese aluminum carbon and strontium ferrite magnets are being scaled for industrial use. And the aim of this solution is to reduce our dependency from the rare earth elements that are imported from third countries. And the second pathway is recycling, which aims at the recovery of rare earths from end-of-life neodymium ferrite boron magnets, like the goal of the NeoCycle project, coming from motors, generators, and with streams. Projects like Permanent and NeoCycle are developing recycling routes, keeping raw materials inside the EU, and the goal is to reduce the supply chain risk. At MNLT Innovations, we contribute as a sustainability leader in both fields in these projects, performing sustainability assessments, including life cycle assessment, life cycle costing, and social life cycle assessment in order to support decision making and scale sustainable solutions. The tool we use to evaluate the real sustainability impact is life cycle assessment, or LCA. LCA is an international standardized method used to measure the environmental footprint of a product or a process through the entire life cycle, from the extraction through manufacturing and transportation, all the way to use and end-of-life disposal or recycling. And by quantifying the impacts such as CO2 emissions, energy and water use, as well as waste generation at each stage, LCA help us answer key questions like which process has the biggest footprint, what does one technology compare to another, and where are the hotspots and opportunities for further improvement. And that's why LCA nowadays is considered as a mandatory tool under EU policy in order to have this tool to prove the environmental performance of the technologies developed within the EU projects. As I said, one of the two key pathways to reduce dependency on critical raw materials is substitution. And this is exactly what the Passenger project is working on. Passenger is a European initiative funding under Horizon 2020, coordinated by INDEA in Spain. The project develops rare earth free permanent magnets by substituting neodymium and dysprosium with manganese aluminum carbon magnets and strontium ferrite in order to replace neodymium and explore the integration of these new rare earth free magnets and the validation of their performance into the electromobility sector. So the process addresses two major challenges: the substitution of critical raw materials in the production of permanent magnets, and also scaling up these alternative magnets from laboratory to industrial applications. These magnets will be tested and validated in real industrial use cases such as scooters, pump motors, and electric vehicles. And in the permanent project, MNLT leads the sustainability assessment, applying life cycle assessment in order to evaluate also the environmental performance of the developed magnets. Before evaluating the environmental performance of alternative magnet materials, we first established a benchmark for today's nominal technology, neodymium ferrite permanent magnets, by using life cycle assessment. The main steps of productions, as you can see on the left, from strip casting and hydrogen decrypitation to sintering and magnetization. The analysis clearly shows that rare earths themselves drive most of the environmental burden. Also, in the graph on the right, producing 1 kilogram of neodymium ferrite boron magnets emits about 76 kilograms of CO2 equivalent emissions, which is extremely high. So the two major contributors are the neodymium, because of the mining and the refining process of neodymium, and also the electricity. The electricity consumption is the second major contributed in the performance. So the key outcome is that neodymium ferrite magnet production is both energy intensive and material intensive, and that's why we should explore low impact alternatives and cleaner energy sources in magnet production. After establishing the baseline for the neodymium ferrite boron magnets, we evaluated the environmental benefits of alternative magnet materials, the one that are developed in the passenger project, manganese aluminum carbon and strontium ferrite magnets. And the results, the LCA results are quite promising. The carbon footprint in the compared to the neodymium ferrite boron production from the manganese aluminum is quite lower, so it corresponds to a 70 to 80% reduction in CO2. And this is mainly because manganese, aluminum, and carbon are far more abundant elements and require less energy intensive processes than the rare earths. And also looking at the strontium ferrite magnets on the right, their carbon footprint is even lower, between 10 and 20 kilograms per kilogram of magnet. So this corresponds to a from 70 to 85% reduction in emissions compared to the neodymium ferrite boron. Of course, when we compare magnet technologies, cost per kilogram is not enough. We must also evaluate the performance per application. Chinese neodymium ferrite boron magnets remain the cheapest thanks to local rare earth availability. In Europe, neodymium ferrite boron magnets cost about 40% more due to import dependency and high energy cost and labor cost in Europe. And now looking on the passenger alternatives, we can say that maybe we cannot have a major reduction in cost because of all that factors that we mentioned. But the key takeaway is that maybe we can still use these magnets for low performance components where cost and supply security matter more than compact size. And of course, substitution cannot fully replace neodymium ferrite magnets boron, but we can significantly reduce the dependency on rare earth by using alternatives rare earth-free magnets. Moving on another project, and I think that we will also have the opportunity to have the presentation of the project by the coordinator later on. Técnicas Reunidas in Spain is also the coordinator of the permanent project, which is a newly Horizon Europe project, where MNLT is also the sustainability leader. The project focuses on circular permanent magnet manufacturing, by connecting the full rare earth value chain in Europe, from raw material extraction to end-of-life recycling and magnet production. So we have three hubs. The hub one dealing with sustainable rare earth supply, hub two circular rare earth innovation, and the third hub is the manufacturing of magnet. As I said, our role, MNLT roles in this project is to assess the environmental footprint of all these innovative technologies developed within the project, and we can see the great potential of recycling magnets either by pyrometallurgy or hydrometallurgy, that we can achieve a reduction by 45 to 70% compared to the virgin rare earth elements. As we discussed, life cycle assessment is, let's say, no longer a scientific tool. It is becoming a regulatory requirement in Europe. There are policies such as ERMA or European Green Deal emphasize the need to measure and reduce the environmental footprint across value chains. And this means that without sustainability data measured through LCA, technologies will not be eligible for funding and industrial development or market approval. So it has become mandatory. And this is exactly where projects like the NeoCycle and all the projects discussed today can lead the way by integrating sustainability evidence early and building circular value chains that are both technically and economically viable. Yes, as we have seen, both recycling and substitution are key strategies in reducing Europe's dependency and enhance its resilience. Altogether, these European initiatives can lead the way towards more sustainable solutions. There are several, of course, areas of collaboration with the NoCycle projects, like changing circular magnet engineering know-how, technical exchange on scaling recycling in Europe, and clustering at EU level in order to connect academia, research, and policy. And the key message I think today is the collaboration. That the collaboration is the key. And we should look on how we can drive this forward through concrete collaboration actions. With that, I would like to thank you very much for your attention. Of course, you can contact us via our website, and we are also active in LinkedIn, where you can stay up to date with our latest projects initiative. Again, thank you. Thank you very much for the invitation, and we look forward to explore potential collaboration opportunities with all of you. Thank you very much.
Thank you very much, Vasiliki. I think that we could see pretty clear the connection and the complementarity between the three projects, the NeoCycle, passenger, and permanent project that gives me the opportunity to present the next speaker. He is Peter Fleming Rubio from Técnicas Reunidas, that is the institution that is coordinating the permanent project. He has to be online. Peter, could you please tell me if you hear us?
Yes, I'm here.
Yes.
Can you hear me?
Yes.
Perfect. Great.
Okay. Give us just a second.
Yes, I will try to show the presentation.
Yes, you can start to share your screen.
Okay. So,
1 second. Sorry, Peter, just one second.
No problem.
Okay, now we can see you and we can see your screen. The floor is yours. Thank you, Peter.
Thank you. First of all, good afternoon to everyone, and thank you for this invitation and the possibility of participating in this event. I am Peter Fleming, Project Manager at Técnicas Reunidas, a permanent project coordinator and Hub 1 leader. So today I will talk about the Hub 1 sustainable supply of rare elements as part of the heart of the permanent project. And I only have 10 minutes, so I try to be as quick and informative as possible. Okay, first of all, what is permanent? Permanent is a Horizon project founded by the European Union, and it's a sustainable rare element innovation and supply network covering the full rare elements permanent magnet value chain. And to achieve this, we have 3 tech hubs that structure permanent pilot and demonstration activities. These hubs organize and connect innovations, thereby validating the permanent model for a responsive, efficient, and sustainable EU rare element supply chain. So the total period of this project is 40 months. And we started in October of the last year, so we have been working on the project for a year approximately. And it's important to mention that we maintain a cooperation with our sister project, REMHAV. Here we have the partner. We are 32 partners in the project, including different companies, universities, clusters, among others. And Técnicas Reunidas is the project coordinator. We have 3 sustainable connected tech hubs segmented along the full rare element permanent magnet value chain and organizing thematic collaborative research and development and supply ecosystem. For example, sustainable rare element supply hub is the hub 1, the hub 2 is the circular rare element innovation, and the hub 3 is the innovative magnet production and user-driven testing hub. But the scope of this presentation is only for the hub 1, sustainable rare element supply. So this hub will anchor a strategic deposit for the provision of rare element and also from mining tailing. It will be complemented by the demonstration of 2 fully scalable hydrometallurgical processes for the efficient and green production of rare elements, carbonates and oxides mainly from different concentrates. So the lead beneficiary of Hub 1 is Técnicas Reunidas, and the partners participating in these activities are Solvay, Pensana, ISMC, Enable, Leonore, Adidas Domendo, and Quantum. What is the Hub 1 main objective? We will create a fully fledged tech hub to secure reliable rare element streams from deposit and sources in the EU S3P mining regions, partnership regions. So to achieve this objective, Hub 1 is composed by 5 main tasks. The first one corresponds to securing a sustainable supply of rare element for the EU permanent magnet industry and other strategic industrial value chain. And this task will initiate a reference EU rare element supply hub model. And in this task will be implemented 3 main activities. The first one is the hub integration of rare element deposit. It is the integration of available identified deposit and rare element sources as members of the hub, of course. That includes samples of different mineral concentrates with various rare element compositions from different deposits and rare element rich mineral tailing of different geological characteristics will be gathered. So it will proceed with a quality control, of course, through physicochemical analysis and deliver them to the hub processing pilot of subsequent activities. The second one is the supply source expansion, is effective identification of homologue deposit and available EU mining tailing to replicate or approach and integrate them into the hub, hereby ensuring a long-term supply operation of the hub beyond the permanent funding and a realistic global EU supply at a large scale too. And finally, the to the hub to guarantee the supply cost and to ensure the effectiveness of the operation in a sustainable way. The second task corresponds to sustainable production and refinement of rare element concentrate from standard rare element sources. And the Hub 1 will capture some viable rare element deposit and transfer them latest sustainable mining standards. As part of this, permanent will involve some deposit, as for example, Matamulas in Spain or Longojo in Angola, to name a few of them. And the rare element concentrate samples will be collected from the different deposit, fully characterized through physicochemical analysis, prepared and delivered to the hub pilot to test our different processing roads. And the source concentrate will be generated, including different pretreatments and concentration techniques. So one last important point to consider is that most rare element ores also contains non-material, as for example, monazite. That means natural occurring radioactive material that include elements such as uranium and thorium. So the partners are accredited and experienced to implement the activity according to the norm activity of the European Commission and following all the IAEA safety regulations. The task 3 is the innovative sustainable refinement and concentration production of rare earth element concentrate from iron ore model deposits. Here some iron ore mining are a high potential rare earth element source, and it will be embedded into our HAV strategy of the EU rare earth element supply. So to diversify the type of rare earth element carriers, it is interesting to study the recovery of these elements from allanite, for example, which is a silicate ore matrix, and compare it with the monazite road, for example, which is a phosphoric matrix, and or is our main concentrate to test our technology. So with this type of concentrate, we can broaden the spectrum of possible treatments. So it's an interesting activity to develop. The task 4 corresponds to sustainable refinement and production of rare earth element monazite concentrate from miscellaneous mining tailing. And although rare earth element content in tailing may be lower than in primary sources, their processing is justified if environmental benefits are considered. For example, some mine site remediations and some land reclamation, for example. Here we will work with mining tailing from Salvaterra de Miño in Galicia, Spain, through the production of monazite concentrate from tailings, mining tailings. And we are currently working with 400 kgs for this concentrate in a pilot activity of the rare technology. And finally, the task number 5 corresponds to innovative, cost-efficient, and green production of rare earth elements carbonate and rare earth element oxide from concentrate miscellaneous mining sources. And this task will build upon task 3.2, 3.3, and 3.4, and shall validate 2 innovative solvent extraction processes at TRL 6 and 7, implemented by Técnicas Reunidas and Solvay, considering the ISO or ISO standards included in task 3.1 and even the IAEA regulation, as I said before. So permanent HAV 1 will demonstrate 2 important points. The first one is the 2 proprietary pilots to TRL 7, ready to be scaled up by means of different innovative solvent extraction technologies, and the permanent value chain flow model. Sorry. Wait. Okay, now I want to share with you some of the strategic and operational milestones of HAV 1. And one of the most relevant are, the first one is the engagement of a norm radiological protection technical unit to provide monthly consultancy services and to prepare all required documentation. Another one is the development of a radiological study outlining the technical process to be conducted at laboratory scale and pilot scale, aimed to identify the necessary safety protocols. Another one is the completion of the mandatory training course required for the safe handling and reception of radioactive material. And finally, this successfully commissioned and initiated operations of the RareTech pilot plant in Técnicas Reunidas. So here I'm showing some picture of the reception of part of the monazite concentrate from the RareTech piloting activities, which was always under radiological control for handling, transporting, or storing it. Here some of the performed activities in Técnicas Reunidas that include the chemical and radiological characterization of the monazite concentrate, some laboratory tests with the RareTech technology. For example, the milling monazite concentrate, the study of 2 leaching stages, and the radiological deactivation of the concentrate and the cerium precipitation. And some of the pilot level activities we have developed so far corresponding to a monazite concentrate milling process to obtain a rare element concentrate that was then traded in a caustic leaching stage to modify the phosphate matrix, changing it to an hydroxide matrix. And finally, the next steps of the Hub 1 are continue the operation of Vertex pilot plant to produce neodymium praseodymium oxide and the rare element carbonate, and send all that samples to Solvay, Pensana, and Filler to continue with the following stages for the manufacture of the permanent magnets. And another one is to continue with the development of the task 3.1, securing a sustainable supply of rare elements for the EU permanent magnet industry and other strategic industrial value chain. And thank you very much for your attention. And if you need more information or contact us, we have a website and an email contact. So thank you.
Thank you very much, Peter. Thank you very much. So we were talking about industrial processes, technologies, but what about the skills? What about capacity building? So the next project is going to talk about this key aspect, in my opinion, that it will be really significant in terms of scaling technologies. So I will give the floor to Cristina Echevarría from the University of Oviedo, that will be presenting the EPS Skills project. Cristina, are you there?
Yes, I'm here.
Okay.
So let me share my presentation. I am not very used to use Zoom, so I hope that I will share.
Yeah, we can see
properly.
your screen. If you can put it in the full screen mode, it's perfect.
I don't know how to do that. Let me.
Yeah, that one.
Like that? Okay.
Yeah,
Great.
perfect. Thank you.
So give me a second. Okay, so thank you, Alicia, for the nice introduction. First of all, I would like also to thank the organizers for giving us the opportunity to present in this workshop our project, and so that the course that we have developed related to the rare earth value chain. So my name is Cristina Echevarría Bonet. I'm coming from the University of Oviedo, and I'm an assistant professor at the physics department of the University of Oviedo. And I'm presenting here our project, Skills REM, or expanding the knowledge and skills in the rare earth permanent magnet value chain, which has been funded by the EIT Raw Materials. So as I said, I'm presenting here a course that has been developed by members of our consortium, of our project. In particular, we have members from different European countries, Sweden, Greece, and Spain. From Sweden, we have people from the Royal Institute of Technology and Spinx, a startup in Stockholm in Sweden. Also, we have Monolithos from Greece. And from Spain, we have 4 institutions like IMDEA Nanociencia, the ICAMSIL Foundation, the Iberian Sustainable Mining Cluster, and the University of Oviedo, where I'm coming from. Okay, so I would like to introduce you just a few of our specialists in this field, which have contributed more or less to this project and to this course. So we have the coordinator of our project, Professor Pavel Kotrabi from the Royal Institute of Technology in Stockholm in Sweden. Also, we have Dr. Santiago Cuesta, Executive Director of the Iberian Sustainable Mining Cluster and General Manager of the ICAMSIL Foundation in Spain. Also from Spain, at the beginning of the project, we have Dr. Alberto Bollero, who contributed to this course from IMDEA Nanociencia, but currently he has moved to a company in Germany, actually the Bosch company, so it's very well known. We have also from the University of Oviedo in Spain, Professor Juanma Menéndez Aguado, who is a specialist in mining exploitation. And also from Sweden, we have Dr. Ina Soroka, who has been the founder of this startup, Spinks, and she's also coming from Stockholm. So we have many other people in this project, but we'll just to introduce you to some of them. So the idea of the project, the idea of the project is to develop a lifelong learning course with the thematic orientation of the rare earth based magnets, permanent magnets, and motors made of these permanent magnets. So as I will explain later, the course has a modular structure. It contains 5+1 modules, and it is designed for a 4-day training if the course is taken as a whole. But of course, it is possible to take just different modules if the company or if the university or the individuals are interested in just one or several of the modules. So our target learners would be individuals who work or intend to work in the different aspects of the rare earth value chain. They can be engineers, consultants, managers, technicians, researchers, or any of the actors of the research and development sector. Not only them, but also innovators who are planning to launch their startups in this rare earth value chain sector. So our customers could be large industrial companies or small and medium-sized enterprises, also consulting companies, or, for example, universities, to cite a few. Not only these big companies or institutions, but also if there is any individual, any person who is interested in taking one or several modules, as I said, we are happy to provide it. So the objective of the project, of the Skills REM project, is to increase the knowledge and the skills on the value chain of the rare earth elements-based permanent magnets. So there are several topics to which the project outputs could be useful. First of all, the education. So we are providing modules in this course related to all the aspects of the rare earth-based permanent magnets and motors. Also the social aspects, so the environmental impact and the social license to operate. For example, if someone is trying to build or operate a mine. And of course, the circular economy, because we are also working or dealing with recycling of our rare earth-based permanent magnets or the rare earth elements. So as I mentioned before, our course is structured in modules. So we have 5 modules, as you can see here, but prior to this, it's interesting to mention that we have a module 0 devoted to the introduction to magnetism, the rare earth elements and permanent magnets, where we are going to, or where we explain all the important concepts related to the magnetism of these permanent magnets. Currently, this module is being moved from the Future Learn platform to the actual EIT Raw Materials Academy platform or webpage. So we hope that shortly it will be available for any individual or any company or university who would be interested in taking this course. So then we have the 5 modules. Module 1 includes the exploration and mining of rare earth containing ores and manners of extraction of rare earth elements from ores and tailings. It also refers to general challenges of the so-called social license to operate. Module 2 is dedicated to current and novel production methods of rare earth permanent magnets. Module 5 covers the main points of design and fabrication of magnet-based devices and components. On the other hand, Module 4 makes you familiar with various methods for rare earth permanent magnets recycling. And last but not least, Module 5 would introduce you to the basic concepts of the life cycle assessment of permanent magnets and their environmental impact. Also, it's worth mentioning that these modules have been developed by different institutions of this project. So Module 0 was developed by researchers from the University of Oviedo, from the Royal Institute of Technology, and from the Spinx startup. Module 1 has been developed by researchers from the University of Oviedo. Module 2 by those at INDEA Nanociencia. Module 3 by researchers of the Royal Institute of Technology in Sweden. Module 4 by researchers from Monolithos in Greece. And finally, Module 5 has been developed by the people in ICAMSIL Foundation. So with this, I think that I'm done. I hope that that you have learned a little bit about our course and that it was interesting for you. So thank you very much for your attention. If you are interested in the course, if you want more information, or if you want to take one of the modules of the whole course, you can contact us, or you can contact our project coordinator, Professor Pavel Kothrabi. You have his details in here, but if you want to contact me, otherwise you have my email on top, on the right top part of the slide. So I would be very happy to help you. And just if you want some more information, you have some links here in LinkedIn, Twitter, or X, and our webpage. So thank you again very much for your attention.
Thank you. Thank you very much. Thank you very much, Cristina. So let me change to this slide. So thank you to the 4 projects that were with us in this first part, of, let's say the main part of this session. But now we are asking you for your participation. We are going into the interactive, let's say, reflection section of this stakeholders project part of the event. So I will ask you to take your phones and scan the QR. Let me know if you are more or less all in the page of the, because I have to start to present. So I assume that you have in your phones the other screen that was before this one. No? Yes, and you start to answering. Perfect. You are so fast. So the first question is, what aspect of NeoCycle do you find most transformative? You have different options. These topics, let's say, were presented during the whole day by different partners and stakeholders. Okay, so sustainable recovery of rare earth elements is in the first place. Interesting. I know that answering anonymously is fantastic, but I will ask you also to justify, someone wants to volunteer, why, maybe, I don't know, Macarena? What was your choice in this case? I will start for you and then others will come.
I knew that. No problem. Actually, I was debating myself between the first 2 options because I think NeoCycle main core is like the more technical, more experimental activities are more aligned with these 2 aspects. So, yeah, the recovery of rare earth elements, the recovery of neodymium, boron, and iron, they're like the main core of NeoCycle, but also the application of these elements once they are recovered and purified in many different high-value applications. And that involves the second option. So I was debating myself between them two, and I finally decided the second one, but actually it could be any one of them.
Yeah, let's say that the three of other ones were just to distracting you, to check if you were, let's say, paying attention today. So we will go to the next one, just in case nobody else wants to add anything. Okay, we will have time. We have 4 questions in here. So the next one is, what connection do you see between digital traceability, material recovery, and upskilling professionals? A little bit of time to read all of them. Okay. Interesting. So let's say that the majority that answers so far, they think that technology, people, and processes are all essential parts for that circular ecosystem. Right now, digitalization is taking also protagonism. Okay. So I will ask someone to volunteer why, with another question, why do you think that material recovery requires new technical capabilities wasn't chosen? Beatrice, that I saw your...
Actually, I answer with the 5 selections. So, in my opinion, all these possible answers are good for the question. But regarding particularly the necessity to develop new technical capabilities, NeoCycle project, in my opinion, is a perfect example of it, because you see that there are different experts that are struggling in order to set the proper way and the proper method to be developed in order to achieve such challenging goals, especially if the amount of the material that needs to be extracted are very low. It's not so easy to have a selective method. So for sure we need to increase this kind of technical capabilities if we would like to improve this method as alternative to the usual availability of this kind of raw materials. So,
even though you choose, like, they have to be all interconnected, so yeah, actually it's not just only, let's say, the 4 options. But let's talk about also the digitalization, because it was like in the second place. Someone who votes this choice wants to take the floor and explain why maybe this is the best choice in her or his opinion. I will choose a person, eh? Peter?
I chose number 5.
Okay, nobody? Okay, we can move along to the next one. I don't want also to put you in the compromise, so I will go farther. So what are the main barriers to scaling the solutions presented today? What do you think? Which are those, let's say, barriers or challenges? Mm-hmm. Okay. Okay, so let's say that in the top of the choices we have the regulatory hurdles and missing common standards. Now is the third place. Okay, this is changing all the time. And technological barriers or low process maturity comes in the first place. Lack of economic incentives or business models, and regulatory hurdles that I already said. So we spend the whole day about talking about technological development. So how is that possible that we feel that there is a lack in the maturity of the technological processes, or we are talking more about the barriers that we find in the market when we want to jump into the market with all developments? I see Raúl making this with the head. That was my call.
I think in general it's a common problem that we are facing of all projects, that normally we stop at TRL 6, maybe 7, and then we don't know how to continue because we have some regulatory frameworks, standards, lack of literature, we cannot follow, we cannot apply, therefore there is no interest for some public administration, even some companies to continue. For me, more than a technology barrier, I would not say, maybe we have to formulate the question in a different manner, okay? The technology, I think it's progressing in the right way. In fact, today we saw some presentations with the perfect vision of the sustainability and how to improve the processes in order to get the final product in the best manner, also with the digital passport. But I think the main blocker that we have is that, okay? That at some point we have a gap, and we don't know how to continue. And I think the European Commission is realizing about that, because it's not only applicable, as I said, for this project. In general, for the reutilization of mining tailings, it's a problem that we are facing. How we can convince, how we can pass from a TRL that it's associated to the R&D, to the commercialization and to the market. So, better if we formulate in a different...
Well, we are here together to reflect. I mean, this is a participation, a participative dialogue, so, yeah. Or next time you do the Mentimeter.
Yeah.
No, it's okay. Thank you very much, Raúl. So I will go to the last one. This one is more, let's say, creative. So the future of critical materials will be, in your opinion, this is like a brainstorming of ideas, of concepts. I thought it was going to be the easier one.
So, critical raw materials. Yes, we have already faced some comments in the very beginning and in the morning session that China has a very high possession of the mines. However, we have unused resources. And this project is a very good example of how to use not the mining resource, but the recycling resource, which is I think it's a very, very important future technology. The other future for critical raw materials could be that how to use critical raw materials in a more smart way than currently, or how can we replace in certain places critical raw materials. So how to lower our dependence on critical raw materials. That could be also a very, very important policy questions in the future, because currently we are very much dependent on critical raw materials. So there are two ways: either reduce the amount or dependence on critical raw materials, or increase our the accessibility for us, the critical raw materials, which includes also global geopolitical actions as well, because if you look at the map, Europe is geographically a very small spot on the map, and critical raw materials happen to be in other places like South America, like Africa, and so on and so on. So Europe presents in these countries currently, I think that should be revised, how Europe is present in these countries regarding resources, because we know very well that China is present almost everywhere. Russia is strongly present in Africa, especially in Sevilla. I should ask the question, how are we in South America? Sevilla is the right place to ask that question. Thank you.
Actually, I think that there is something really interesting that you were pointed out, Peter. That is the multidimensional aspect of critical raw materials, so let's say to the future of raw materials. It's not only, I think that all the options, that all the ideas, all the concepts that we have on the screen, they are all, let's say, not one more than the other one, but they are all interconnected, because we are talking about recycling, as you highlighted at the beginning, but it's also a really complex but promising scenario, right? Because we are talking about also the dimension, the geopolitical dimension of it, that sometimes is in another level, but maybe sometimes it's not up level, but it's at the same level of the rest of the things, like the challenging economics, or maybe the technological development. So yeah, this was the last one, but since we are in a stakeholders workshop, and there is something quite important in the new cycle approach, actually, is in the website. We also we want to remember our partners and also the stakeholders that were joining us today, to join also the stakeholders network that is available in the website of the project. Okay. And that's all from my side. I just want to thank you all for coming today, for all the panelists that we have also remotely during this the whole day. I apologize for the interruptions, let's say the delays that we suffered during the day because of the weather outside, but I think that it was a really successful and fruitful event. So thank you very much.